start our session. I want to ask you, if you have a question, we're going to use the microphone because people that are following us in streaming cannot hear the questions. Yes? So raise your hand in order we can move quickly while the speaker is answering. Yes? Okay, we are going to start with jobs. He's going to send a pig, an angel, and a cactus walk into a blender. And he even has his t-shirt. Yes. The name of the presentation.
Can I start?
Yes.
Hi, my name is João, and today I'll be presenting the pig, an angel, and a cactus walking to blender, descriptive approach to visual blending. But before going into that, let me explain a bit about the context in which this paper was developed. So my PhD topic is how to computationally produce visual representations of concepts. And my approach is basically, this is not working, conceptual networks, which have concepts and relations. And obviously, I want to use the concepts and the relations among these concepts, but also with semiotics, which means that the visual representations I'm going to produce have position, have color, and shape. These visual characteristics, I need to use them according to the meaning of the concepts. Right now, I'm just focused on this one, and with visual conceptual blending, I'm testing how can I use analogy to produce symbols. And the first question I had to solve was, how do I represent these subjects? Which structure do I use? Because basically I need a structure that allows me to deal with concepts, but also with relations, to easily use information about these relations. So okay, this is our approach. This is a pig, okay? And having the organization of mental spaces as an inspiration, instead of parts, okay? So I see the pig as a whole, but as parts relating to each other. And a concept it's important to know its graphic object. What do I mean with graphic object? So this is a graphic object, that is a graphic object, and that is also a graphic object. Actually, all you see there are graphic objects. And the thing is, the graphic object can it just continues. It's like Matryoshka, the dolls that go inside. And not only that, but for a graphic object, there is a list of relations, descriptive relations. So for example, we have this pig, and then you have the eye, the left eye, the right eye, and the nose, they are inside the head. And also the left eye and the right eye are in the upper part of the head, and the head is in the upper part of the body. So what happens is, this is correct, this is correct, this is correct, this is not correct. So I have these rules that allow me to produce visual representations and to see how can I from one move to another and change it according to that. So based on this set of relationships, I have this, but I also have this, I have this. So these are all correct according to those relations. And what this allows me to do is an easy process of blending. So I have the cactus, and knowing that the head of the, if we have when changing the part, then the rule applies to the new blend, so the arm just moves there. But then in the cactus, the arm just goes around the body of the cactus. So what happens is that the face of the pig can just move freely there. And if we map, for example, the belly, so that inner circle, that just goes inside the body when we map it. This goes inside, and this is incorrect. Okay. So right now I've explained the structure I use, so I want to move to the paper I'm presenting. Okay. So I've selected three concepts: the pig, an angel, and a cactus. And what I did was I gathered some people and I asked them, please draw me these concepts. Please, each of you draw me two different ways of visualizing the concepts that were there. This is a drawing that the person did. So this is the first step. Draw the pig, then annotate the parts of the pig, give it names. So for example, the one that's "ad" written in Portuguese. Okay. And then I asked them to point me the prototypical parts. So the prototypical parts is what makes a pig a pig. So right now, you see the tail is a prototypical part. The nose is also a prototypical part. We'll get back to this. And also the relations that are present in this representation. So then from this, I went to this. So I based on the drawings, I translated it into a fully scalable vector graphics in order to be able to work with it. And also the relations. These are the base relations, Okay, so right now I've explained the structure and the input that I give to the blender, okay? So let me describe the system. So it's a blender which has two components, the mapper and the visual blender. Right now, and the paper is only focused on the visual blender, that was my part of the work. So I'm not going to focus much on the mapper. This is an input space, okay? This is for cactus. And they are given to the mapper. The mapper works, doesn't works right now, and it produces analogies. And the analogies are basically, so the nose of the pig matches with the halo of the angel, the eyes match. So these are the mappings, and this is an analogy. And it gives me not just one, it gives me several. And then these analogies are passed to the visual blender, and then I give to the visual blender two representations, so that visual representations in the initial relations. I give it to them. And then what happens is, inside the visual inspired evolutive engine that allows me to evolve the plants. And the fitness function I use is based on the relations. So for example, have this. Even connected to the body. So that's what I want. This is a bad plant. Okay? So this one, it has these relations that are not satisfied. So the way it works is the system evolves into satisfying those relations. So this is how it evolves. See? And then it produces the plants, and it gives me the plants. Okay, so during the inquiry, I asked the participants not only to draw representations for the concepts, but also to draw me plants. So draw me pig, draw me cactus, and now draw me what a cactus pig might be. And this is a cactus angel. This is what my system produces. What the cactus angel would look like. It's not exactly the same, it has legs. Okay, it's more or less the same characteristic. Weird. Okay, and then, okay, pig angel, mine. Cactus pig, mine. So you see, the system is able to match what the participants thought would be the blend. But not only that, at least I considered more unexpected. I wasn't expecting this collapse. So this is a big angel. So you don't have the wings, but you have the cloud and you have a halo. And this is a cactus pig, so he has a pot. So basically, it's a pig that grows in a pot, maybe. And then you have the big angel with pig ears, a tail, and a belly. And what's interesting here is that there were done by composition process because they matched the body of the angel with the body of the pig. And as the pig has a tail, then the big angel has a tail too. And then a cactus. And might even be shy. In the first place, so instead of wings, he has like these cactus arms. So I don't know if he might be able to fly, I guess not. And then we have this one, which has some interesting attributes that were not there in the first place. Come to another interesting point, which is this one. You can more or less see there's an angel right there, right? And then you see with like lines. So you might think, okay, it's a plant, maybe it's a cactus. I don't know. It's the same thing. It's an angel cactus, but you cannot see it, can you? So what we did was we went with a perception experiment. So basically, we wanted to know who to have attention. What I mean with that one is, I don't think the prototypical parts, they don't have it, or they don't have the prototypical parts from both input spaces. For example, yeah, tail, nose, prototypical parts, the spines and the pot, the tails, cloud, nail, and actually the fitness too, right? If they have satisfied relations or not. So, good blend, bad blend. You cannot see the pig, can you? Good blend, bad blend. So you can see hairs. You can see maybe it's a pig because he has a pigtail. Then what's that? It's not an angel. Might be a person. Maybe it was like Tony said. Maybe a person went on one side and instead of a fly went a pig. I don't know. And this one is a very good blend. This is not as good blend, is it? Okay. And then we looked at what we collected, and basically you can see that. So up there is the number of correct answers. So correct answer is I look at a cactus pig plant, and if I say it's a pig and it's a cactus, I have 2. If I say something else that it's not correct, I have 0. So that's how many names they got correct. So if you look at it, in the bad blends, the percentage of getting none of the names right is always higher. And the percentage of getting both names right is always higher in the good ones. And also, by at least one of the input spaces on the good exemplars, and in this one, they identified pig, but they didn't there. I want to talk about the future right now. So what is, so one of the things that I want to try out is to implement the optimality principles in the fitness function, because it might be useful to see which of the principles can I use, if I can use one or two or every one to use them at all. I don't know. It's a challenging thing to do it because it's not obvious how I can do it. Okay. Then context. I want to use context in the example this one. This was done by one of the participants, and why angel pig land. So you get a pig, and you know that the angel is in the sky where there are stars. So an angel pig might be a pig that is in the sky. So this, I want to do this, and obviously guided evolution, because my motivation to do everything I'm doing is I'm a designer, okay? I'm not from computer science. So what I want to do is say, I want a pictogram for a green, fast car running over a person. And I want the system to suggest me possible visual representations, but I want to say, this looks nice. I want it to evolve in this direction. So that's what I want to experiment with. And for me as a designer, it would be really useful. So that's where I'm going with my PhD, but I'm doing step by step. So now this is what I have to present you with. I really hope that you like the presentation. You can see more information there, or just look at the paper. Do you have questions? Just one more thing. I have postcards. So if you want postcards, come to me, give me your feedback, and I'll be glad to give you postcards, okay? I cannot give you t-shirts, but I have postcards, okay?
Sure.
Are we on here? Yes, okay. So I'm wondering how much of the results that you get depend on the nature of the representation. Are those particular, could you describe them in other ways? Do the results depend on the complexity of the representations? What happens if you had other kinds of relations?
Yeah, that's a good question, because what I'm doing depends a lot on how I represent it and on the relations, obviously. This is my approach right now. It's more easy that I don't need to annotate everything, because it might be on the left of something, but then the other thing is on the right of that. So there are I'm not sure if I answered you, but work. But that's this is the first experiment.
If you can find a particular representation that's not unique, that is, you can encode it in a different way.
Okay.
You can compare the results.
Hi.
Hi.
Thanks a lot for your presentation. I have a question, how you can distinguish, for example, what's the characteristic of one angel? For example, the body is not very important, but the wing is the feature. So I want to know if you try to find these distinguished characteristics or not.
Right now I'm not doing that, but when I started doing this to show me what are the prototypical parts, was because I was already looking forward to do that. But
at this moment, I'm not doing that. It might be interesting to include that in the fitness function, because, like I said, when you're trying to generate, but you also want it to be like the prototypical parts are like a main thing. To have a blend, I need the prototypical parts of both. So yeah, that will be the way to.
Characteristics in the pitch, I don't know. So it shouldn't be just graphical.
Yeah.
You can find in other parts too.
Yeah, exactly. Thank you.
One question on there.
Thank you. Thank you so much for the presentation. Being drawn by humans.
Yes.
So was that fit into the system, or that's just used for comparison purpose?
Yeah, it was just used for comparison.
Okay.
From the participants, I only got the base ones. I got the pigs, I got the cactus and the angels. And I was already thinking of how can I evaluate this. So I thought, like, if I'm generating blends, it makes sense to ask people to draw me blends and then compare and see, is my system able to generate the same thing they did?
Question.
From the last question, did you find that your participants to each other, and did you ask them to evaluate each other's at all? Or?
They did. Well, there were some really interesting blends that my system cannot produce right now. For example, there was a cactus in which the participants replaced all the spines with tails. So it's a cactus full of tails. Right now, I'm not able to produce that. But then I had more creative. First time I spent my birthday without my family and my friends. So I'm really family. Okay, so thank you.
Happy birthday to you. Happy birthday, dear flower. Happy birthday to you.
Happy birthday.
Thank you.
That's fine. That would be good. Thank you. And if you don't mind putting this in your pocket, flipping it on.
Thank you. Okay.
Perfect. Just thank you.
Okay. Ahmed is going to talk to us about CAN, Created Adversarial Networks, generating art by learning about the styles and deviating from style norms. Thank you very much.
Hello, everybody. So today is not my birthday, but it's coming in 2 weeks. Creative Adversarial Networks. This is a joint work between me and my student Bin Shindi and Muhammad Al-Husseini, who is now in Facebook, and Professor Mariam Mazouni, who's an art historian at College of Charleston. Our system generates these kind of images by learning about art style and deviating from style norms. I try to explain what that means. Obviously, everybody in this room know that there are a lot of literature from evaluationary processes, things like genetic algorithms that generate images and have a fitness function and try to modify them. The hardest part here is how to really find out this fitness function that has aesthetic sense. There has been earlier system that, and it's still going, that use human in the loop, where the computer explores the creative space and human play the role of evaluator. Recently, in this community, there have been a couple of papers that emphasize the role of perception and cognition. So basically, I quote here, before a computer can draw, it must first learn to see. This is the title of a paper from ICCC 2 years ago, actually last year. Anyway, images, generative deep networks that generate images. In particular, the most successful is the generative adversarial network, GAN, which was very successful in achieving this goal somehow. So for example, this is one of the variants of GAN called DC GAN, using a convolutional network that generate images that looks like bedrooms, which is very reasonable, a low resolution version of bedrooms. It's very nice that the machine can generate this. This actually generates images that are novel sample from the class. So they are not imitating exact samples from training data, but generating novel samples that looks like or have the same distribution as the samples. So what's good and what's bad about GAN? So let me explain a little bit how it works. So there are two networks here. The generator network that takes a random vector and transform it to what looks like a random image. And there is a discriminator who is trained to discriminate between real images from training data and the random one generated by the generator. At the same time, the generator receives this signal about how the discriminator can identify the random images, whether it's real or fake, and use that to improve its job. So at equilibrium, the discriminator will be able to tell whether it's coming from training or coming from the generator. If we take this model and train it on art, so if you feed it here art images like that starting from Renaissance all the way to today, and train it on art, what kind of art it will generate, or what kind of images will generate? Is it art at all? And I'll try to convince you that GANs are not creative at all. It's basically, by design, it's trying to emulate the distribution, so it's not trying to change anything creative. So the generator is trained to generate samples that fool the discriminator to believe they are coming from the training distribution. So ultimately, the GAN will just generate images that looks like the existing art. And if we think, let's think about ultimate case where the generator can cheat and have access to the actual distribution. So it can pick up one image from the distribution and give it to the discriminator, and the discriminator cannot tell the difference. So it will basically not generate anything creative at all. So there is no motivation in the network to generate anything creative. There is no force that pushes the generator to explore the creative space. In fact, just a couple of days ago, we found this paper, or a code, actually not a paper yet, that generated art by training GANs on art images. And in fact, really what you see here is things that looks like flowers and things that looks like portraits, trying to imitate the distribution, but not generating anything new. Psychology. So our model is based or motivated by a psychological theory of aesthetic evolution, comes from Colin Martindale, a psychologist, who based his theory about based on Daniel Berlin work. So Berlin, basically, the psychological concept of arousal is of great relevance to studying aesthetic phenomena, in particular arousal due to external stimulus pattern. And he used the term arousal potential to refer to the properties of stimulus that lead to raising arousal. And most significantly in this domain is novelty, surprisingness, complexity, ambiguity, and puzzlingness. And he coined the term collective variables, that I think all of you know about, to refer to these properties collectively. And it's well known that according to the one curve, basically too little arousal potential considered boring. So people will not like things that are too exciting for them. That's what's called the Wundt curve, which William Wundt, the father of psychology, came up with. So on the other hand, habituation stimulus become boring for you. And this is exactly what the basis for Martindale theory, which is arousal potential was the motivating force working on artists and art audience, driving the evolution. So basically, Martindale hypothesis. This will direct potential and hence the likeness of art. So artist has to push to increase arousal potential at any time, basically to compensate for habituation. But in the same time, if they push too much, they will fall in the negative part of the Wundt curve. So basically, that's the principle of least effort. But how that can be achieved? Increasing arousal potential can be achieved in different ways: novelty, complexity, any of these variables. But in particular, why artists come up with new styles every once in a while? Why came up with Cubism or Impressionism? Why things change? So he explained that by the interaction between two cognitive processes. Basically, we can think of it this way: that there are two ways to do new art. Either increase novelty by increasing regression. Limit, you have to increase the novelty by actually decreasing the level of elaboration to the point that you move out of style, because you already have explored all different subject matter and different ways within the style, so you have to go out of the style and try to do something. So this is exactly the motivation behind our work. So we focus on building an agent that tries to increase and deviating from style norms, but in the same time have to avoid moving too far away from what's accepted as art, not to fall out in the negative parts. This is the basic motivation. In other words, the agent tries to explore the creative space by deviating from established style norms and thereby generating new art. So here is our model. So it's similar to GAN in terms of have two components: a generator that generates random images and discriminator. The main difference, one of the main differences is that obviously we train on art as well, but we have style labels for this art, and the style labels here is basically what style: Renaissance, Baroque, Impressionism, something like that. And the main difference is that our loss function here has three components. The first component is similar to GAN, which is basically the discriminator try to discriminate between real art the discriminator learn about styles. So it tries to actually learn about what is the style of that art. The generator received a second signal, which is the style ambiguity. How ambiguous is this for signals? Generate things that convince that's an art, established art. At the same time, it tries to generate things that are ambiguous in terms of style, doesn't fall within any styles that are established. How to achieve style ambiguity? We can do that. The style class posterior. Instead, we suggest minimizing the cross entropy between the class posterior and uniform target distribution. I will not go over the details about why we do that, basically because this will have a hefty penalty because it goes in infinity. But in a nutshell, because of time, this is the objective function here, or the loss function. This is the art or not art loss for the discriminator, and this is the style classification loss for the discriminator. For the generator part, this is the art or not art loss, and basically this is the style ambiguity loss. So let's look at, so this is basically some of the images that we generate as picked out by the authors. As you see here, there are a lot of varieties of things that looks abstract or looks like landscape, looks have textures or very simple or very complex variety. So let's try to validate this. It's very hard actually. So we trained the model on about 80,000 images from the Wiki Art collection, about 1,000 artists from 15th century to 20th centuries. First, let me show some qualitative results based on some baselines. So the first baseline is GAN, trained on art. And the second baseline also the same thing, except that it's higher resolution. We add more layer to make it high resolution. And these are top and bottom rated images based on human subjects. And as you see here, we found that GAN, when it trained on images, it generates images that is not, you cannot recognize any styles, it cannot recognize any genres or subject matter. It's basically random compositions. It might look nice in some cases, it might look bad, it might be creative or not, we don't know. On the other hand, if we add style classification loss, only the style classification loss to the GAN without the ambiguity imitating art. So we can now generate things that looks like scary portraits or deformed landscape or things that looks like religious painting or with strange architectures. So it's started getting better in emulating the art. This is by adding the style classification loss. Getting more appealing. So let's now talk about how to validate that quantitatively. So these are the top ranked images by a human subject, and these are the lowest ranked images by human subjects. And how can we evaluate? That's very hard because we have two-way evaluation here. We want to evaluate whether CAN or GAN generate images that are as creative as real art, and whether CAN is generating images that are more creative than GAN. And it's very hard to evaluate this question. Thanks for the first speaker today who explained how hard is it. And also evaluate the role of the style ambiguity as well. So we conducted 4 different experiments to show that. The question is which real images we should use by artists we should use to compare. Since we want to try to elevate creativity, we need to compare with art that is considered to be novel and creative at this point in time. So we cannot compare. So the first set is an abstract expression. To compare human and machine ability to distinguish between abstract art and art drawn by kids or even animals. Because some people say that expression art is nothing other than just scrambling. So, and they found that actually the human and machine can discriminate between these two things. So we use human subjects will have some familiarity with this. These are the sets that we are using for that purpose. The other set actually is a set from Art Basel, which is for contemporary art from last year. So we pick up 25 paintings at random after excluding art that has clear figures or clear brush strokes, and we restrict art to be contemporary after 1950. And this is basically our set. It's our set of 25 paintings that we used. So the first experiment, we asked 2 questions. Do you think the artwork is created by the machine or by a computer? And the second question, just to rate the likeness, how you like that art. And we compared the GAN, the DC GAN 46, the CAN, the Art Expressionist, and Art Basel collection. And here is the ranking in terms of human artists versus computer. So Expressionist art is 85%, CAN 53%, Art Basel 41%. But if we roll out the fact that that GAN or CAN actually imitating or copying actual art, they are generating novel samples. Having novel samples closer to the human rating here, like art expressionists, tell you that this is more creative in that sense. We repeat this experiment. The reason is we thought that asking the question first about whether this is from the machine or the computer might generate random guess because there is no basis for answering the question. So instead, what we did is surpriseness and ambiguity and complexity, and then there is no much difference, but actually there's a significant difference in the answer for 6 questions. So to compare this to experiment 1, here again, Art Expressionist has 85%, exactly the same. CAN improved a lot to 75%. To 256 resolution, so it's higher than this and gives 65%. And Art Basel comes last at 48%. All right, let me move to experiment 4, where the goal here is to evaluate the effect of style ambiguity loss in contrast to just style classification loss. And here we're trying to judge the novelty and the aesthetic appeal. For that purpose, we refer to art history students as our subject. The other can and one was the style classification can, no style ambiguity, and ask which image is more novel and which image is more aesthetically appealing. And the result is about 60% of the time people prefer can images at the two scales. But actually 50% of the time the answer for the two questions were different. So they are not necessarily picking the same image every time. The last experiment I want to talk about is we try to test whether the images generated by can be considered art to start with. If these things looks like art or not. The paper from Snapper that tried to discriminate between try to evaluate human ability to judge abstract expressionist art compared to kids' art. So they asked a couple of questions. They asked to rate the intentional, the visual structure, the communicative, and the inspirational aspect of the image. And they hypothesized that human subject will rate work by artists higher. That human artists human subject will rate actual art higher in these scales. So we compare Can, Art Expressionist, and Art Basel using MTurk, and the surprise was subject found images generated by Can intentional, visually structured, communicative, and inspiring higher than the actual art by human, which is very surprising and against our hypothesis. We don't know what to make of that. These are the numbers here. Anyway, this is I'm almost done. So this is the top-ranked images according to human subject based on these 4 questions and the question from the first experiment. And that means the conclusion, which I'll keep it open, basically, that can generate something novel that's appealing for people, and we don't know exactly what that means. So there are a lot of questions that probably require more experiment to come up with a clear conclusion. Thank you very much.
We give Raphael.
Very interesting talk. You think similar process, or if you think that this might generalize to other domains?
I'm not aware of anything similar in other domains. I think it's applicable to other domains as long as you have that style ambiguity applicable in that case. I know in the domain of art generation, there are a lot of works that try to generate art, but again, focus on emulating art. So the goal is emulating, not creative, but it's the same domain, basically. There was a question.
Well, thank you. I think if I understood it right, your model is based on optimal incongruity theory, right? So we've got this wound curve, and I think you say that your motivation is to move outside the spot to either invent a new subject, this style, right? Now I wonder how strong the notion of novelty really is here, because we basically just do interpolation on a corpus of images. What's
Yeah, that's definitely hard. So you have a distribution of what's called art, all right, and you're trying to come up with novel. That by design, what we are doing is we have these 2 forces. So one force will try to stick to the distribution, and the other force try to. So as a result, we believe the image generated by GAN when it's trained on art compared to the images that generated by our model. So GAN tries to generate new samples that doesn't really follow styles as well, because but there are significant improvement in the quality of the results and appealing of the results once you add these two forces that contradict each other. So we believe that our model try to generate things that are pushing the boundaries but not going too far. But it's very hard to really justify this claim.
Thank you for your talk. That was really playing with the loss function was the way to really improve and make neural networks and deep neural networks creative, and you did it before we did, so that's really good. My question is, 250 by 250 is not going to cut it for an exhibition. How does the model scale in terms of the size of the images?
That's a really good question. Most of the GAN adding more layers, which, as you know, require more and more training data, and that significantly improves the results right away. Going higher is feasible. You just need to have more images to be able to train these results. You can always add more layers and have more details, and if you have more data. So it's, I think that's also what we're doing.
Two more short questions, please.
I just want to ask a small detail. The fact that you're using mechanical Turk is, so I have this question that the users on mechanical Turk, they are trying to rate as many as possible. So they spend really less, they try to spend less time. So first, my question is, what was the average time per user? And second, since you are using abstract expressionism, remembering my talks, my informal talks with a bunch of artists, the way that one of the ways that they judge the success of their painting is that how much the audience spend time looking at the painting. This is not just the only dimension, but it's one dimension. So in that sense,
it's very hard with MTurk. So the only thing that we did, which is similar to the Snapper paper, basically we asked user to spend at least 30 minutes and have constrained that you have 30 seconds before the answer, and we restrict that. But definitely that's a valid point. That's also and actually improve in our favor a lot, because people have more time. These days, it's really much more time and money to do it the other way around.
Well, thank you very much. We don't have time for the other question,
But you can ask him during the break. Thank you so much. RDC metric to generate and assess ingredients combinations.
Okay.
Just put it in your pocket.
It's fair. Okay. Good morning. I'm from Brazil, Pontifícia Universidade Católica de Minas Gerais. I do not speak English, then I decided to read some notes during the presentation. Sorry about that. Much has been discussed on how to measure the creativity of artifacts generated by specific metrics, random approach, among others. And in the last edition of this conference, a metric called RDC was proposed, independent domain metric. That is, it would be applicable to different domains in order to evaluate the creativity of artifacts. The objective of this paper is to I will present the step. To make clear what the IDC metric is, I will give you a brief explanation. IDC combines novel and various to be new and valuable on a particular domain to be considered creative. Novel is calculated by bias and surprise, and value is calculated by synergy. When the metric was proposed, two application domains were used to describe the use of the metric, fashion and card games. And to use the RDC, each artifact has to be described using the region-dependent model. This is just be described in this work. No recipes are generated, but only the ingredient combinations. A creative ingredient combination. To answer that, we need to define how novel and value will be calculated in culinary domain. If you want to calculate novel of an artifact, we need to have a knowledge database with artifacts already known. These three questions clarify the needs to calculate the novel. How different is the new ingredient combinations compared to the others? How can we represent them in dataset? And how can we compare them? It takes 4 steps for novel to be calculated. Step 1. We collected recipes from online database. In this case, we downloaded about 50,000 recipes from we described the method of preparation and the amount of each ingredient. The result was a knowledge database with 50,000 rows, where each row has a list of ingredients as listed in item 2. Like this, just the ingredients. Step 3. We need to structure the data. To use the RDC metric, an artifact needs to be described as a set of region-dependent pairs. That is, a set of key-value pairs. So we need to find a representation for each ingredient. And in this case, we use flavor compounds that describe each culinary ingredient. There are about 1107 flavor compounds mapped in the reference book. The authors of a related work called Flavor Network and Principles of Food Pairing from Nature magazine had extracted all the information from the book and provided us with Naroli's Handbook of Flavor Ingredients. Then we get all the data from this book and put in database. And finally, we need to build a data set with ingredients lists. And how can we put all data from an ingredient list in a single row? We know that an ingredient is a set of flavor compounds, and the ingredient list is a set of ingredients. Then so we decided that each row of the data set would have the number of columns equal to the total of possible flavor compounds. In this case, 1107 columns. To represent the recipe, each flavor compound present in each ingredient of the list has its value increased. If the same flavor compound occurs in more than one ingredient, it will also increase. In this case, the first and second arrows, the flavor compound are present in only one ingredient of the recipe. The third arrow the flavor compound is shared by 3 ingredients of the recipe, and last arrow, the flavor compound is shared by 2 ingredients of the recipe. In this way, we could represent the data according to region-dependent model, even to shared flavor compounds. If you want to, if you want to calculate the value of an artifact, we need to discover what aggregate value to an artifact. Here we also have 3 questions to clarify the needs. Which makes an ingredient combination valuable in the culinary domain? What characteristics add value to the ingredient combination? And how can this be represented? And the food pairing hypothesis can help us to answer that in culinary domain. According to the food pairing hypothesis, if the ingredients of a recipe share flavor compounds, then it's very likely that this recipe is tasty. This image represents the network of existing culinary ingredients. If 2 ingredients share some flavor compound, then there is an edge between them. We call this network synergy set, which is a representative graph of the field. In this case, is sharing flavor compounds. The graph which has the most interconnected vertices represent the most valuable artifact. And we have 2 samples, low value. Then in this work, a recipe is represented by a subgraph composed by the ingredients of the recipe. Look at this example of ingredient combination generated using RDC. The ads represent the number of flavor compounds shared between the ingredients. And how we put all this together, the creative flavor pairing. We have a genetic algorithm called Pairing Builder. It generates ingredients combinations that will be evaluated by RDC. We can calculate novelty because we create a data set, and we can calculate value because we have the synergy set. The generating process continues until the artifact is evaluated as creative. Just an observation, the RDC metric is being evolved and turned into a completely redesigned API. It will be a RESTful API accessible from any programming language, and we have not yet put the latest version in GitHub because some details are missing and all the documentation needs to be adjusted. The experimental analysis was performed in 2 stages. In the first stage, a study was carried out in the allrecipes.com, whose objective was to verify if there was convergence between the RDC metric of ingredient combinations and the popularity of human-evaluated recipes. At this stage, RDC was calculated only for ingredient combinations created by humans. The objective was to verify if what was considered creative by the RDC usually coincide with what the users consider tasty. As can be seen in the graph, the convergence was verified since the recipes considered more creative. The recipes considered more creative by the RDC usually coincide with the recipes evaluated more tasty by humans. And the worst, always, also. In this graph, SR is social ranking, extracted from allrecipes.com. It's the number of users that like the recipe, prepare the recipe, things like social network. And RDC is the creativity calculated for the recipes evaluated by humans. In second stage, once convergence has been verified and high RDC values are usually related to human-friendly recipes, novelty value and creativity by RDC comparisons were made between samples of combinations of ingredients generated by creative flavor pair and those created by humans. The result shows that it was possible to generate as creative results as those created by humans. Some work in our area of culinary claims that only a small potential of ingredient combinations is explored. People usually repeat combinations that have been explored. Thus, computational creativity in this domain also helps to expand this potential exploration. We also evaluate how results can influence users. For this, we invite a Brazilian chef and showed him some artifacts generated. He chose that one and create a complete recipe from the suggestion of the system. He considered the artifact interesting because it suggested an unlikely combination that he would hardly explore, that is guava and beet in the same recipe. That's it.
Bueno.
So maybe I didn't quite understand. Is this working? Yes? Yes. Maybe I didn't quite understand. Do you combine the novelty score and the value score directly? Because in other work in particular engineering design and the design world, they are sometimes weighted and weighted with other things as well. So you have a weighted combination of these various attributes of assessment. It's just a straight combination.
Can anyone?
Está a perguntar se combinas só os dois ou se pões algum peso. Se tens peso para a novelty, se tens peso para o outro.
It depends. Okay, it depends on domain. Let me show. We have a penalty function because we want to discard the artifacts that have high novelty but no value, and we also discard high value with no novelty. But the weight is changed by the domain. Now we are trying to apply that in music, and it's too many hard. And we think I will insert the weight for novelty and value, but still working.
Another question? Raise your hand before, please.
So you said that you translated the information in the book of flavors into a database. Can you make that available, or is that not?
The flavor compounds data?
Yeah.
Yes, the team from related work from Nature magazine, they provide us the JSON with all data.
Oh.
Then it's public. We will put all this in GitHub with the API and the 3 domains that we already tested. And I don't know the date because we have to write some documentation and adjust some things, but it will be public.
Okay, thanks.
Another question? Okay.
So as I understand it, and forgive me if I'm wrong, but the value function is based on the synergy, which is how many flavor compounds they have in common.
Yes.
Correct? So for example, what would be the synergy of potato chips with fried potatoes or something, or baked potato?
We just have the ingredient in the book. Then we cannot differentiate red guava from white guava or potato to potato. The weakness from this API is we have to provide a template. If we do not provide, some combinations useless are generated. If I have 5 ingredients and we do not put a template, the genetic algorithm can generate 5 different teas. And 5 teas does not good.
Right.
We have to.
So potentially you could add in more elements to your value function, and
Yes.
that would work perfectly, right?
Well, I have a question. If nobody else has a question, we have time. Food and all that has a very cultural attachment, yes?
Yes.
The hypothesis you had, the other slide you had before, it depends. Yes, the food pairing hypothesis has a lot to know. I was thinking, for example, in avocado. In Mexico, we ate avocado in salads, in sandwich, but as far as I understand, in Brazil, you use it in very funny ways for us. Yeah, I think you mix it with milk or water. So that's a kind of contradiction, no? Maybe both work. So how do we manage this?
The food pair hypothesis is just verified for North American. The Asian, I don't know, Asian, they think the opposite of the food pair hypothesis. The scope to North American and East European, but we have a problem.
For your presentation.
Obrigado.
So the last presentation before we go for lunch is going to be presented by Amilcar, and it's called Blend City.
And this in the pocket. So, good morning, everybody. Which is the first author, the PhD student. Take the flight, so I'm making the role of the PhD student, trying to be shaking. Well, actually, I may shake at a certain stage because there may. Well, let's see how it turns. Conceptual blending, because you have already learned about that in something that comes from Divago, is an evolution from Divago, and we'll focus on the Blendville, which is the system that we are now working with. Some experiments that we have done and some future work and conclusions. Well, skipping the part regarding conceptual blending, you know, we have input spaces, we project them, we mix them, and we add some flavors and so on, and it goes on. One of the problems with the conceptual blending is that the way we project and the way we combine takes us to a potential huge number of combinations. So to control of conceptual blending. The theory proposes 8 optimality principles, which have been. There's no consensus about how we should use them, but we are trying to learn more and more about that. We are, in the past, we had made Divago through results from the PhD of Francisco Câmara Pereira, which has this overall architecture. There is a mapper that produces analogies, structural analogies from the 2 input spaces. Then there is a blender that projects parts of the original input spaces guided by the analogy, projects into a blendoid, which then is evolved using a genetic algorithm whose fitness function is of optimality constraints. This was Divago. So input maps, projections, and evolution of the blends themselves. These are examples of input spaces in Divago. They are described with triplets, but we can visualize them as graphs. We have 2 examples here for horse. Divago also uses frames to control the evolutionary process. So the frames take a role in the computation of the optimality, of some of the optimality constraints, and so have a role in the process. The use of frames was suggested by the theory as ways of including some prototypical representations that should be favored somehow. Oh, the reverse. Blends that match frames should be favored because, in principle, they contain prototypical information. So these were frames used by Divago. And Divago used 5 optimality principles, 5 from the 8 proposed in the concrete project that finished less than 1 year ago. We took Divago and improved it in several aspects. Ability of input spaces instead of being passively waiting for input spaces to be given. So it is able to look for input spaces in a big input space. We implemented a new mapper, a new analogy maker, and actually João is also using it. It's the mapper that he mentioned in his presentation. We have the flow engine available online, used by the project, so it is available if you look at that link. And we also made an analysis of the optimality constraints. We have made several studies to gain more knowledge about the optimality constraints. Most of this is published in previous editions of this conference and also in was the past and during is to improve the search for blends. So the way the blends are evolved. So it is a search process. We have a space of blends and dealing with multiple analogies instead of just one, because Divago are trying to explore multiple analogies, dealing with multiple input spaces, with the idea of enriching the population of potential blends and possibly be able to discover points in the blend space that previously were untouched, unreachable. We are also exploring alternative measures of quality by improving the optimality constraints and improvement of scalability and performance. So we rebuild it from scratch. Now we have a new program, the threaded approach in the evolutionary process. So this and now we focused on this blind view, which receives a list of input spaces, a list of analogies, a list of frames, and produces an initial projection, which is not represented in this it evolves using a prologue engine to get the best blend we can find. Well, we are now dealing with multiple analogies. If Divago could, for instance, take this analogy between horse and bird, a horse is a bird and a hoof is analogous to wing, but we can use alternative analogies, so we can relate two input spaces in multiple and in the projections of new blends. We are improving a bit the frames that we used in the past. Local frames are a kind of frames that compare relations and concepts in a given spaces. This was already used in Divago. We are adding new two types of frames, the pattern frames that look for specific patterns and value blends where those patterns occur. Delta frames, it's the same idea, difference of specific patterns. The difference here is that looking just for patterns, and here we are looking at to patterns and relate them with the input space. I may say, maybe I may clarify this a bit more. In this case, for instance, we are looking for a relation that existed, could exist in one of the original input spaces, but now connects different concepts. While here, if we find, okay, so here we are trying to pinpoint or to encourage the emergence of patterns that somehow change from the origin, same concepts to the same relations to different concepts. We will see an example of that. Optimal. As I told, Divago used 5. Then we made some studies. It is not quite clear for us yet which constraints, optimality constraints, may make sense, but now in this things. So we are still using the topology we want the new blends to keep topology from the input spaces. We are using simplified version of integration and pattern completion. So here we try to value blends that cover existing frames, so to preserve somehow meaning. And now we are adding entropy-based constraints, which were not proposed in the original theory. The idea here is to prefer, look at this, this is occluded. We typically prefer simple versions of what we don't know to other versions. So the idea is to try to be simple, try to use replication of the same stuff to give preference to that. So so we are trying to favor compression, actually. That's why we opted to use measures of entropy. We are particularly using two measures. One simple, we call it the zero order measure that just tries to identify the entropy looking at the relations, just at relations. And a second version, first order, that looks at sequences of two relations. So pairs entropy. And then we have secondary constraints that just act at the level of structure and not at the level of the meaning. We'll skip this. The genetic algorithm, I will chromosome that contains not only the blend, but also the analogy or analogies that were used in the projection of the blend. So this is in the, we call it the local analogy. The first population is produced from the input spaces according to that analogy. Mutation, we are applying mutation both in the local analogy, which means if we change somehow the local analogy, we have again to the blend, because the analogy produces change the blend itself, or we may go directly to the blend and add a relation, remove a relation, small changes. We are not using crossover because we didn't find a crossover that does not destroy the population. We need an crossover, we didn't get it yet. This is the genetic algorithm running. This is a run of 500 or something epochs. The current best the median is here, and this is the current first quartile that so apparently it is behaving as expected. Evaluation. How did we evaluate this? Our idea was, if we have Divago that was used in the past, and in the past Francisco Câmara did several experiments with it, why not compare the system with the results we got in the past? A way of understanding whether did in the past. Because we are experimenting these measures, these new constraint. Took one experiment from the thesis of Pereira. We are using the same usefulness which were in novelty as non-typicality, usefulness. Usefulness is worth takes a goal, so takes some goal to attain, some final blend that we to get, for instance, to get a Pegasus at the end, to take the horse, take the bird, and reach the Pegasus. So we applied this and analyzed what happens, which one of the constraints we are testing. Topology works more or less as expected. I will only underline the surprising things we got. We didn't find a direct correlation between topology and novelty, which is surprising. In our opinion, we have to change the way we are computing topology, because it's only a local topology and does not look enough for the structure. That's why there's no correlation. Frames are behaving as expected, so nothing to say now. By using the delta frame allows us to different situations. This one is nice because we found something that we could compare to a wings and thus can fly. It's just a delta. Well, entropy as expected. Some problems with the measure of novelty. We have to improve the way we measure novelty, but we kept the novelty as Divago did, because we for useful want to compare, want to produce blends to attain a goal. We want to discover novel things, not to discover what we already know. This was just for the purpose of making the evaluation. Well, and before Rafael shakes, I stop here. Please, questions.
Thank you, Amilcar. So I'm thinking that when you model blending as an optimization problem, that you effectively make it a convergent thinking problem. You think of the example of the flying pig. System would say, well, a flying pig is a police helicopter, right? So you'd have to jump outside the system allow you to do that? Because in part, the optimization is trying to get an answer at the
yes.
But when you constrain yourself to do that,
this surprise may came in the case of a blend may came from the way you combine things. We have seen examples of surprising things in the icons of the pig and so on. It's the kind of stuff we want to make in a systematic way. How to make it? You are right, the experiments that we have conducted are mostly convergence, and the first thing to recognize is that if we have a goal, of course we want to be convergent. So, but this is just for experimental task. Them to the blends to combine with different stuff. That's why we want, in first place, to deal with multiple input spaces and with multiple possible alternative analogies living together, and deal with at the end, otherwise should go towards something to people, although surprising, okay? What makes a blend meaningful? That is the question, of course. We are trying to understand whether the application of frames or image schemas to detect prototypical parts of things in the blends that are in the population may indicate us a potential good blend. Okay? It may combine things from different input spaces, but and it may at certain stage be quite different from the input spaces. But when from an helicopter may be more meaningful, although containing surprising connections that are not in the prototypical part.
I guess what
I cannot prove you this, no, of course.
That's
all.
one answer is not often a creative answer. Novel answers are often obvious answers. Novelty doesn't mean non-obvious. So putting the wings on the pig is a good answer, but it's an obvious answer.
Yeah.
Which means it's not a creative answer.
Yeah.
So can you get good answers that are non-obvious answers?
Getting the wings in the nose of the pig is at least surprising. It may not be very useful for. It depends on the application.
Yeah, I like this work a lot. It seems like it's moving things forward. You're focusing on the processes involved, but I want to go back to representation again. It's nice that you don't
Thank you.
How do we get rid of this little thing down here? Now there it is.
Hello.
No. No, it isn't.
I'm happy to share.
I can loan you this if you want.
Nope. Just in case.
Just use this.
That's fine. We're friends. Okay, I think we're ready to begin the next session.
Are you sure?
This is the
It's definitely working.
ICCC session on music. And the first paper you can see is Daniel Johnson, Robert Keller, and Nicholas Weintraub's paper on learning to create jazz melodies using products of experts. And here's Robert Keller to present.
Good afternoon. I'm Bob Keller. I'm the second author, and the other two authors are undergraduate students that worked with me on this project last summer. We're interested in what we call improviser, which is a contraction of improvisation advisor. It's a software tool that is designed to help people learn to improvise, particularly focused on jazz. And it has a number of features, one of which is that it can actually improvise autonomously on its own using a variety of different methods, but one of the main methods it uses heretofore is generative grammars. So in addition to being able to improvise using a grammar, improviser can learn a grammar from transcription of a solo, say by a famous artist. And it can also trade improvisations with users in real time. So trading is something that jazz musicians are fond of doing after they play their multiple choruses over a song. They will typically use 4 bars intervals or maybe 8-bar intervals and trade back and forth, improvising with each other. So this is the user interface for improviser, just to give you an idea of what we're talking about here. It features a lead sheet, as we call them. The lead sheet is a combination of a set of chords, which are the things that are the letters, symbols above the staves, and then the melody, which are the notes on the stave. And so typically, a jazz musician has to listen to the chords and create a melody on the spot that goes with those chords. Hopefully that resonates with the chords rather than clashes with them in some sense. A little bit of background for our current work. A few years ago, actually presented at the first ICC in 2010, we used something called deep belief networks for improvising. This was after improviser had already been started, but we were trying to take a different tack, which was to learn to improvise using minimal musical knowledge. So basically treating music as a bunch of bits and not telling the machine that it's actually doing music, and learn how to do that. And that was partially successful. Used the notion of a deep belief network as defined by Jeffrey Hinton. But there were some problems with it. One, the training was very slow, and the performance of it was also rather slow. So we never did actually integrate it into improviser. And that sort of sat on the shelf for a while. And meanwhile, the whole deep learning thing happened. And so this past year, we got interested in trying to reincarnate this work. But as it turned out, we shifted it to a different model, which is recurrent neural network rather than using the deep belief model that was pioneered by Hinton. So the general idea as a sort of black box is you have a network, and in comes a chord sequence telling you what the chords are, and out comes the melody. So the network is essentially playing the role of an improviser. And again, this is to kind of give people an idea of what an improvisation over a specific set of chords might sound like. It's not to replace the performer, but rather to assist the performer in learning how this might sound. And so learning by a network takes place by you give it a chord sequence and you give it an exemplar or a set of exemplars of melodies that you that you could play over that, usually derived from some performance where things actually are more or less correct. And then the network corrects itself, or you correct it, by adjusting the weights so that the things that the network produces are more in line with the things that that are in the exemplar. So a multi-layer network with something like this, we have a set of nodes, and each node is a weighted sum of inputs to that node, and to that weighted sum is applied some kind of a transfer function, which will create the ultimate output of the node. And then in a multi-layer case, that output is fed into the next layer, and the same thing happens again, and so on till you get to the output layer, and that's your result of the network. So the vectors that go in are, say, in the space of r to the m, and things that come out are r to the n, real numbers. So now we're using recurrent networks, which have the additional complication that the output, part of the output, is fed back as input. So you have the melody coming in, you also have the previous state, as it were, as part of the input, and then it's producing melody. And the advantage of this type of network is that the network could, in principle, it could play indefinitely, whereas a non-recurrent network has a fixed amount of time that it could play. And these are trained using the idea of backpropagation through time. So backpropagation through time, as I'll explain a little bit more, essentially unwinds the network and uses backpropagation as in the case of the non-recurrent network. So it's a fairly time-consuming process because the number of steps that you unwind is proportional to the length of the melody that you wish to generate. So we do encoding of our chords using a bit vector where multiple notes are turned on at the same time. And then the melody that comes out is a bit vector which generally has one pitch on at a given time, so time is going across. And it also has to have some things to say, when is it a sustain versus a new attack, and when it's a rest. So those are accomplished by bit vectors, which are largely one hot, except for these additional pieces that indicate rest or not, or attack or not. So in actuality, we don't have a network that just produces the note, but rather it produces a probability distribution of notes that you would like to play at each time step. So the output of the network is actually not just a note, not one of these vectors, but it's a probability distribution saying this note is in some sense more desirable than some other note. And then going stepwise in time, the note that is produced from the previous step is used as one of the inputs to the network, and that allows it to determine its output based on that note, and so on. So you have the state moving across as well as the previous note to be used by the network in producing the next distribution. And then to get the actual melody, these distributions are sampled and to select one of the notes. So you basically toss the dice and you pick things that are higher probability typically, but you can also pick things that are lower probability depending on how the dice lands. So, so that's the idea. And then the training in this case uses a loss function, which is based on the score, which is the product of the probabilities. We take the negative log of that, and that's the so-called loss, and that's what you want to minimize using this backpropagation through time. So in '97, and a little bit later, applying it to music was the idea of long short-term memory nodes of our network. And these make the nodes inside the neural network a bit more complicated, and they're intended to solve a problem which is known as the vanishing gradient problem. So the idea is if you're unrolling these networks for a really long number of time steps, then eventually the gradient, which is used to train the network to achieve the minimum cost function, kind of dissipates. And so at the end, where you have an error that's normally backpropagated to the beginning of the network in time, that tends to have less and less effect the more time steps that you go for. And so these LSTM nodes were designed to overcome that process of short-term memory. So going back to the jazz part for a moment, we have a desire to produce what I would call convincing inside jazz melodies. That inside means that they're notes that ring or resonate with the chord progression as opposed to notes that are outside. So at the top, we have an example of what might be considered a good melody over a particular chord, C major 7. And then on the bottom, we have a couple of examples that are not so good. So on the left, we have one where a lot of the notes are outside, and improviser indicates this outside character by coloring the notes red. So red is basically a bad thing unless you really know what you're doing. And some professionals can play outside and make it sound really cool, but a beginner or intermediate player, typically if they see a lot of red, that's not a good sign for their melody. And then on the other side, we have something that's bad because the contour is jagged all over the place. So it's not going to sound very pleasant because it doesn't have any kind of smoothness to the progression. So our network is supposed to generate things that don't have either of these defects. And so we use a product of experts. That's the sense in which the title is being used. We have an expert that deals with the case of making the pitches resonate with the chord. And then we have a second expert, which is the melody expert that learns intervals that make the contour of the melody smooth. And so those two experts are working together, and we take the product of their probabilities to get a net probability distribution, which we then sample. So an overview from a fairly high level would be this idea: you have the interval expert network and a chord expert network. They're working in parallel, and then they take the product of their outputs, and that is the way that we get a distribution for sampling for the final result. And that product of experts idea was also due to Hinton in 2002. So here's the way it looks in terms of actual melodies. You have, at the top, you have the interval expert working, which is trying to smooth out the contour, and those arrows below are showing kind of the jumps in the intervals, whether they go up or down. And then below that, you have the chord expert operating, which is assessing the value of different pitches relative to the root of the chord. So the chords are changing, and so at every step, that has to be reevaluated. And the overall system then takes the product of those two. So here's what this looks like in terms of actual probability distribution. At the top, we have the interval experts distribution. It's saying that you want to get a high probability for placing notes where the heat map is darker and lower probability where it's lower. And then similarly for the chord expert, we have at the places where the chords are articulated, we have a probability distribution there. And then we take the product of those two, and then we sample it. And so we end up with a sample distribution, which ultimately gets turned into actual notes that get played, as you see below. So to train a network such as this, we can use a variety of different corpora. The one I will demonstrate, if I have time to demonstrate, is trained on a large number of different things that are both academic sort of licks and solo transcriptions. Thank you. And we're training a network that's two-layer recurrent neural network with 300 of these LSTM nodes in each layer. And we train using a library known as Theano, using Python program, which is not part of Improviser. And that produces a connectome, which is the terminology used these days to represent the weights in a neural network. So that's a numeric file that we then input to improvise to achieve improvisation. So here's what part of the training corpus would look like. We have a ASCII notation for both chords and melody notes, and we have all these are coded in files, and then those are translated into the bit vectors that are used to actually train the network. And so here's an example from this connectome. We have the training exemplar below is just a sample, and then what is actually produced by the combined network at the top. And just to show you, there's quite a bit of variety as possible. These are additional licks that were improvised from the same connectome. So one of the ways we can illustrate this is we can trade with the user. The neural network can produce the melodies in real time, and we can trade with the user, listen to the user, actually not really listen, but we can allow the user have space to play, and then the user, the network can react and play something in parallel. And so I think I have enough time to demonstrate that to you. Here is Improviser running, and we just check that we're using deep learning, which is the code word for the network. And I have this keyboard that I borrowed from Donald Trump, small hand keyboard. So we'll make sure we have the keyboard input set right. And just to give it a test, we're going to play the background. Okay, I'm going to turn up the chord volume a little bit so you can. So you hear the bass and drums now. So what the musician has to do then is to play, and in this case we're going to interact with, so we're going to do passive trading, and we're going to let Improviser play the first 4 bars, and then we're going to react to it. So it gives you an idea of how it can play. And it can actually improvise without trading too, on its own, pretty much keep track in real time. So just going back to the talk for a moment. This is an additional control panel that we have that allows the contributions to the product, which we actually compute as not as a product, but as a sum of logs. We can adjust the weights on those logs, and we can get the network to be more adventurous or less adventurous. So more adventurous would be like relax the smoothness, for example, or make the chord, the melody notes be more outside, perhaps. So we have some ability to do that. We can also load other connectomes besides just the one that I used there. So just to evaluate, we don't have a lot of user tests yet, but the recurrent network is able to improvise effectively, and it can more or less compete with grammars, which were what we used heretofore. But the training is still slow, even though the performance is real time. And a kind of a flaw that I experience from time to time is that sometimes the learning seems to be a little bit too rote. And even though that the corpus is really large and the network is only 300 nodes in each layer, it seems like it does pick up on some things and reuse them a little more than you might expect. So that's something that we really need to work out. And so just to close then, we're interested in these topics as future work. And I invite you to participate by downloading the software, including the source. It's out there on GitHub, and you can try it out and give us some feedback or even contribute to the project. So thank you.
No question.
Right. So Bob knows I've been tracking Improviser for some years. I like the program very much. And I like the fact actually that it develops through student projects as well. So it's not just your pet project that's been going on all this time. You've got students involved, and we see so many jumps forward. So I really like that. When you did the demo just then, and it was trading 4s, there was a bit where you played over your 4, which is quite common when we play 4 bars each, that we kind of invade the next person's 4 bars. But I noticed that it kind of waited for you to finish. Would I have been right?
So it's actually giving me 4 bars to work with, yeah.
So the fact that it didn't start playing straight away in its own 4 bars.
Oh, in its own 4, yeah. Well, that's a characteristic of the network, just deciding to leave space there. So as you know, rest is one of the kinds of notes, as it were, that we produce, and that's just what it learned to do at that point.
Thanks, Bob. I'm curious about the fact that you had two experts, in your view, two nets, one looking after harmony, the other looking after contour. I assume you've tried using one, because it seems to me that the whole idea of these things is they're multi-dimensional learning, and why you separate those dimensions seems unusual.
Right. It just wasn't working as well as we would have liked with just one. And so that's, it actually was Daniel, first author, who actually had used this kind of a model for some polyphonic composition, who suggested that. But yeah, it just wasn't working out. So maybe we could go back and somehow make it just be one network. But I think a message is that the product of experts is something that could be used in a variety of creative endeavors, not just improvisation and not just by neural networks. So you can think of separation of concerns, a la Dijkstra was a proponent of doing that. It's probably a good thing to have available, let's say.
My question is kind of a follow-up to the previous question. So in your training for the model, were you, if I recall, the inputs were the chords, correct?
Yes.
And the output were the melodies?
Yeah.
Did you actually experiment with actually providing the chords and the melody as inputs so that the recurrent neural networks learn dependencies between previous notes?
That's one of those future topics.
Okay.
Yeah.
Okay.
So being able to actually react to the user as he or she is playing would be
okay.
something.
Yeah, it would be interesting to see.
Yes.
Okay.
Thank you. Hello? Yeah. Great talk, Bob. It's great to see a demo, a live demo actually going on in front of everybody. That really takes guts. So my question is about the long short-term memory aspects of all of this, which is a really important thing. That seems to me to be the central contribution. So the difference between the sort of noodling jazz that you get in a bar and the performances that amaze people and go down in history is that there's a sort of coherent core of material going through those important performances. And so do you think, what's your opinion on whether this kind of technology can capture that sort of, I mean, it is longer term structure, but it's also a more abstract kind of structure.
Right.
Do you think you'll be able to get at that?
I think you probably could with a network, and it may require another layer above, which is focused on that long-term aspect. So we actually are working on the ability to use motifs, although we're not primarily working with networks right now. But in the grammar sense, we think that we can handle that situation. But experimenting with doing it with a network is another topic of interest, definitely.
The way you're doing your experts, first of all, you have two viewpoints that you're looking at right now. So I have kind of a two-part question. Do you think there are any other viewpoints that would make this better? And,
sure.
And so if maybe you could talk about that for a second.
So for example, you might have a duration expert, or how long do you hold the note expert, and that's another thing.
How do you do that right now?
It is pretty much just done by sampling the exemplars. So we assign a duration when the thing is learned, and then that's basically it. Okay. Yeah. Now I should say there's also an underlying metronomic track that tells you when you're on the beat, for example, or when you're on the half beat, and that information is part of the input to the playback and the learning process as well.
Okay.
Yeah.
And the second part is the way you're doing the expert combination says that they are independent, right? Statistically independent.
Right.
Is that?
That's not
good
truth.
thing or a bad
Truth.
thing?
It's not the ground truth, but
Is it okay? I mean,
I think it's okay.
Is it okay if you keep adding experts? I mean, some of these things are not independent, I think.
It's up for up for exploration. That's all I can say.
Okay, one last question.
So thanks for the presentation. This was very interesting. When sitting here, so as a practitioner in jazz, or at least a former one, probably I should say.
Okay.
I feel like there's definitely different characteristics in improvisation that rely more or less on kind of predetermined structures. So the licks that you know or the riffs that you know are very much a core part of the improvisation in bebop, for example, right? When you move into, and I'm saying this partially for the benefit of people who are uninitiated, when you move closer to more contemporary modern jazz, especially like New York City free jazz style, it's very much more about making sense in the moment and a communication to a depth that possibly you would say is not in more structured jazz styles, right?
Yeah.
So the question I have is for these really unstructured domains that are within jazz but are highly, let's say, generative and socially generative, do you see this grammar-based approach? And I know you can kind of teach motifs in there a bit. I'm wondering if like kind of that element could potentially be expanded towards this larger super free form kind of style of improvisation, or where the challenges are, I guess, in this approach versus more generative approach or domain.
Yeah, so actually we have another type of grammar that we use, which is a transformational grammar. And so it could conceivably learn things that would respond to something a user plays that's a little bit more or less structured, you might say. That's, I think, the closest thing that we have to offer at this point, but I understand where you're going with this, and it's certainly a valid question.
It's a super abstract thing to try to train on.
Yeah.
Right. So
yeah, so we're more interested in more or less the straight ahead type of jazz as an educational vehicle rather than a performance tool currently.
Right.
Thank you.
Thank you, speaker. Thank you, Bob. Our next speaker is here from Georgia Tech, and it's Mason Breton. It's going to be delivering the paper you see on the screen.
Sounds good. Okay, hi everyone. So my name is Mason. I'm a student here in music technology, and Gil Weinberg's my advisor here. And Larry Heck is someone that I worked with when I did my internships at Google, and I was fortunate enough to be able to do music generation as my research project during those internships. So a lot of this content of this paper and a lot of the stuff I've been working on the past couple of years has been inspired by the domain of language, where Larry comes from, especially in dialogue and communication. So I've been pulling from techniques that are used in that domain for music generation. And also, I wrote this paper like over a year ago now, and a lot of the things well, not a lot of things. There's some very core components that are in this paper that I still use, but then there are some things that I've departed from. So I just want to show like a couple examples of what has spun off from the content of this paper, and then sort of give you the main ideas of what I'm still using, and then hopefully describe what I've departed from. So just as an example, I've been able to use these techniques for just improvisation given a chord progression.
1, 2, 1, 2, 3.
So giant steps, and then the piano is going to start improvising. So that's just given a chord progression, generate a monophonic melody. And then I've been more recently, my research here at Georgia Tech is specifically on robotic musicianship. So how do I take all of that stuff and then put it into a system that has all of these physical constraints and this notion of embodiment? So this is something that's that's just the composition. We just sort of let the system go and generate its own thing, given the constraints of the robot. And then also I want to be able to interact with my system. So this is sort of a call and response sort of paradigm that I developed. So those are some of the applications that have spun off from this work. And sort of the core idea that I want to convey for this is that for most models, for music generation, you are, I guess you just saw this in the previous presentation, but you're feeding something in, and it's either some context or some history, and you're either predicting like the next timestamp or the next note, and that might be a probability distribution of notes, or a single note, something that's like one hot encoded. So that's sort of that first technique, and that's something if you're familiar with the Magenta project at Google, their system is just take in a bunch of note sequences and then predict the next one, and that's how their LSTMs or recurrent neural networks are trained. So what I'm doing here is something, instead of just predicting the next note, I want to be able to predict the longer term idea, or a longer term musical structure. And so that structure might be encoded as some numerical vector, but then from that vector we can either do some nearest neighbor search for doing like unit selection, or do some sort of reconstruction to give us not just the next note, but a sequence of notes. And this is inspired, actually, sort of going off what Dr. Margarita was just talking about, that the theory of jazz improvisation. There's this theory that jazz improvisation predominantly consists of inserting and concatenating predetermined musical structures or pre-existing notes. So you're just using, I have all of this muscle memory, I know I've done all of these years of practicing, I can sort of just concatenate all of these ideas that I have given this chord progression that I have. So that was one inspiration. And then also the techniques that are used in text-to-speech technology, where they're doing concatenative synthesis. And so they don't have to learn all of that underlying structure from the bottom up, but they get some of that structure for free. And so I wanted to take advantage of something like that as well. And then also the need for addressing embodiment in my robotics research. And so there's, if I'm just predicting note by note by note, it could generate something that is incapable of, that the robot is incapable of playing just because of its physical constraints. So instead I want to sort of generate this broader idea and then say, okay, give me this, now generate the sequence of notes that allows it to bring this idea to fruition. So what is the optimal sequence of notes that allows this idea to come about? So, so I guess really my talk is mostly about learning that numerical encoding and then what you can do with it. And so that encoding is basically these higher level semantics. So if we think about it as an analog to language, it's similar to identifying like the topic about some dialogue or about some speech. And so you're projecting this data. So from this, we're projecting letters or sequences of letters. So we're not just making comparisons in the ASCII space, but some higher level, more meaningful space. So we can now compare these two pieces of dialogue, and not just by saying this one has 5-letter Ds and this one has 5-letter S's. But now we can say this one is about sports, this one is about politics or food. And so we want to get that. What is the actual idea that's being represented? So I want to do the same thing with music, where we have a small snippet or a small chunk of music, and we learn some representation, some higher level representation of that music. So one way of doing that is to use something called an autoencoder. And so for this, what I did is I take a measure of music, and then I do something like a bag of words representation. So I'm taking features out of that measure of music. So this could just be the notes, the pitches, the rhythm, so both in unigrams and bigrams. And then you put this into a big vector. It's a bag of words vector. And then for the audio encoder, you're just compressing it and then reconstructing the existing, or you're reconstructing the input. So the input is equal to the output. And what you get is this encoding or embedding in the middle, that 500 vector length sequence of numbers, and then we can use that. Hopefully, it's learned something meaningful, or put it into some abstract space that is meaningful enough to have some higher level semantics that are being captured in the music. And to evaluate if that occurs or not, we can mix two pieces or two snippets of music and sort of linearly interpolate between them and see if like the result is sounds like a mixture. So here's an example of that. So that's the first seed. That's the second seed, and these are the linear interpolations between those two. So that sort of validated that my feature selection is okay, because there was some coherence between what was being linearly interpolated. But then we can go a step further, and this is a technique where I want to learn something that's more semantically relevant to context in music. So if we're doing this unit selection task, we want to be able to select units that should essentially be next to each other. And so the hypothesis is that two measures of music that are next to each other in a piece of music are semantically relevant, or are somehow related, and I want to capture that relatedness. And so I do this using something called a deep structured semantic model, in which I project the features into this space. And then I have mirrors of that same network that we're using. So the feature vector goes through through the input, and then it's projected into that 128 ReLU space. And what I'm trying to do is maximize the similarity between adjacent units or adjacent measures of music. And so you get this sort of push-pull response. And so hopefully the space that's learned is something where the music has similar things that will appear in similar spaces within whatever abstract space is being learned. So I can maybe it's better just to show it. So if each of these is there's 10,000 unique measures in here, and so each yellow dot is a measure. This is just the network trying to put together things that are similar, and we want it to put together things that are similar to us and similar in terms of how we interpret music and listen to music. So this is the space that's learned, and then you'll hear some examples of what was learned. So those are the nearest neighbors in that little area. So now that I have a way of measuring essentially semantic relevance, or some sort of similarity metric between two units, I want to be able to concatenate them and use that to generate music. And so we have an additional cost or metric, which is used to then concatenate these pieces, and that's the concatenation cost. And essentially all it is an RNN where we're feeding in one hot encoded representations of each note, and then we're predicting the next note. And so we have a model of prediction. And so we can evaluate the quality of the join of two units by using this concatenation, or essentially what is the probability that this next note occurs given what it's already seen in these previous units. And so what we're evaluating here is units of different sizes, essentially. So I can use a unit of 4 measures, 2 measures, 1 measures, or I can just generate 1 note at a time, and I'll show an example of that. So this is the input, and then this is the predicted next unit. So here it generated 4 measures of 2 units each. And then, so to evaluate that, we can measure the mean rank. So if we take a list of random units, and we're like 49 random units and 1 truth, so 50 total, we can measure where does the truth, if we were to rank all of them, where does the truth lie? So using the 4 different scenarios in which we're using units of 4, 2, 1, and note level units, we can compare the performance. And so our best performance was with, for ranking, was where we got a mean rank of 5.9. And then that went down for other unit lengths. And then we did a subjective evaluation in which people listened to what was generated, and we wanted people to listen to essentially the naturalness of the contiguous 8 measures, and then also the likability of the 8 measures. And what we found was that we asked people to rank these according to different metrics. So the first one was transition between the first 4 measures and the last 4 measures, the relatedness between those, the naturalness of just the last 4 measures, the likability of the last 4 measures, and then the overall 8 measures. And so what we would expect is the stuff where it's all pre-composed, it's just the 4 units would be the best. But there's actually some Goldilocks zone for overall likability, because if you have smaller units, you have more flexibility with what you're capable of generating. So between 2 and 1 units, we got our best performance. And that also was shown up. This was mean rank, and this was the frequency of a unit length being the highest ranked. And so we got also an overall likability, both 2 and 1 were the best performers. And then finally, in my last minute, I just want to show that we were able to generate, but then if we want it to fit to a chord sequence, there has to be some sort of post-processing. So what's generated is basically going to be influenced by what is the initial seed that you give it, and then it will start generating from there. So here's an example of 2 different seeds, and then also there's another post-processing step which adjusts the notes in each unit so that it fits the chord to the chords appropriately. Now here's the second version with a different seed. That's it. Thank you.
Hi, thanks for the presentation. I have a question for you, which is, have you guys looked at how, like, so sometimes when you hear folks in these styles improvise, you'll hear motifs from other pieces of music, either from jazz or from playful nursery rhymes or from Beatles music. And it's just an example of a kind of insertion that is perhaps within that style blending or music blending kind of realm. Do you guys have a sense about how your system could potentially do that? Even if you feed a bunch of Beatles examples, will it fit Norwegian Wood into a Coltrane tune or something?
So my assumption is, because when it's training like the recurrent part, if you're training to generate and to predict next, if you give it a seed that's already like sort of Coltrane-ish, it will continue to generate that in that way. But if you were to give it a seed that's like Beatles, it will continue to generate. So unless there has to be another driving force that says, throw this in here every once in a while.
Okay, so there's some meta level that you would need to add.
I think so.
Yeah. Okay, yeah, I dig that. But even then, it like the notion of taking a melody for, I guess part of my question is just how you guys deal with outliers, maybe of inputs that are valid kind of jazz or bebop inputs, but are clearly not well represented in your training corpus. I guess maybe that's
I mean
that's just a general kind of we need to train more kind of thing.
Yeah, I mean that's just I think a general question for learning in general. And that's part of the reason I'm using unit selection here, is because I've noticed when you, if you were just to let it generate all the notes and all of the structure by itself, it usually smooths out all of the interesting stuff. And so if we're using unit selection, at least I know that some of that lower level content is still going to be contained within the generated melody.
So congratulations on a really impressive piece of work. My question is about the harmony. So you said at the end, in almost throwaway remark, that you do some post-processing to sort the harmony. So I'm guessing you just force the notes into the right mode, right? Nearest note or something like that. So what I find myself asking is, well, why didn't you just go back and put the harmony in as an input at the front? Because it seems to me that is likely to do something interesting.
It is, I agree. Okay. And so I've been working very slowly and putting a data set together that has all of that information, but it's just not available. So I didn't mention this, but we used 120 improvisations and then all of Wikiphonia, all of the real, the lead sheets that were on Wikiphonia, and that was my training corpus. And if I had stuff with chords, I've been labeling myself, but it's just such a slow process. And I've been doing some transcribing myself as well, but it's hard to get that data, and that's why I left it as just a post process.
Yeah, sure. Okay, thanks.
Very interesting presentation. Really creative mix of ideas. So good work. My question is, I really like the fact that you are sort of having an analogy between techniques using text language versus musical language per se. My question is sort of like, I guess, I want to hear your opinion. I was sort of surprised by the fact that you are using unit selection as like trying to find similarity between unit selection, which I guess the analogy with language is that you would look for similarity in words, right? Words that appears around the same context would have the same meaning. And to me, unit selection in the way you're doing it in the music looks more like maybe sentence in language. You know what I mean? And we know that sentence similarity in text doesn't apply as in that similar way as word similarity. So is that something that you thought about in terms of design, where maybe for similarity you would look for, I don't know, like maybe intervals of notes, and then unit selection would be your sentence, and then that way the mapping between language techniques, textual language techniques and musical techniques would, yeah, what's your opinion on that?
Yeah. So the analog to language isn't perfect, and so there are differences like that. But I think that the main takeaway is that music is hierarchical, just like languages, you have like this word, sentence, paragraph structure. And so this, it probably is closer to, actually that DSSM paper was for ranking whole documents. And so that's why it's not just like a word-to-vec method, it was more of a, can we encapsulate a broader topic instead of just the meaning of a single word. So I think that there still is some work to do in terms of generating the structure of even like midterm length durations of pieces of music. And so that's like future work.
Yeah, the reason why I was actually pointing that was because I recognized, for example, that like in the unit selection, like some units in the music, obviously the contiguous units would have, you could expect them to have some similarity, but there's like a point where there's an end of a sentence, like an end of an idea and then the start of another idea. I guess this brings me to actually the way you trained. Did you actually try to separate like groups of units and then train them together in order to not have that bias?
Yeah, so here, my goal was really just to concatenate appropriately two contiguous units, like two measures. In recent work, in a paper that's currently being reviewed, it's like you do get that longer term structure, so it should, in theory, pick a unit that does like resolve or something that would be like equivalent to having a period or something like that. So, and it seems to be working when you do have that longer term input.
So Mason, great work. Thank you.
Thank you.
My question's sort of related, and that's about to the unit length. So were they one measure units, first of all?
Yeah, we use one measure, two measures, and four measures is what we evaluated. Yeah.
Okay. And secondly, then there's no, can I just confirm there was no transformation of that material apart from the harmonic fit?
Right, from what you heard. So actually, I did, so from that initial corpus, I did some augmentation, like transposing, and then I also did some stuff where I would add just random intervals in between notes, which doesn't really seem valid, but with our robot, it's something that, our robot's very capable of playing big intervals, but like very small intervals, like if can't really do a chromatic scale quickly. So just me artificially adding some intervals to that, and then hopefully of the millions that were generated, hopefully a subset of that will sound okay. Yeah.
Okay.
Okay, that had to be our last question. Thank you very much, Mason. Our next presenter is Sarah Harmon, and her paper is the Narrative-Inspired Generation of Ambient Music.
Okay, does this microphone work? I can hear. All right, so hi, yes, my name is Sarah Harmon, and I'm going to talk about narrative-inspired generation of ambient music. So I started this project because often when we're building what we consider to be computationally creative systems, or really any generative systems, we tend to feed our systems input or conceptual rules that directly map to our output. We build a poetry generator, and it constructs generations by considering properties of poetry, like rhyme or meter. Or maybe we're building a game generator, and that's going to construct designs that are based on properties that are assumed or learned to be desirable for games. And it makes sense to us that we build systems like this precisely because it is a direct mapping. Even if we tell machines to go off and find their own features, chances are those kinds of features are going to be from something that looks pretty similar to our output. But this isn't really how humans work. And when we create something, we're pulling semantic information from everything that our senses have picked up. every little memory that our brains have stored. We invent recipes after we visit a modern art gallery. We compose music after watching someone dance. Now, just because humans do something and perform or behave in a certain way, that doesn't mean that computers should necessarily follow suit. But what this does help us recognize is that there are distinctions we can make regarding how different kinds of systems approach problems. So some systems purely gather and or analyze a set of semantic information that is specific to their expert output application domain. And in my paper, I call these intra-inspired systems. So they're inspired to use semantic features commonly salient to humans that exist within their own application domain. Other kinds of systems might understand how to integrate a set of semantic knowledge that is outside their expert application domain or genre, preferably at or beyond the level of human capability, and thereby inspire something new. This type is a much rarer system to see, but I do think it's a good goal for this kind of community to consider. I call these kinds of systems extra-inspired, which doesn't mean that they're necessarily more inspired than intra-inspired system. What extra is just referring here to this outside idea that they're considering semantic features from outside of their own expert domain and creatively translating them to generate something interesting. So both intra and extra-inspired functions can be useful, but what these categories are illustrating is the fact that the source or the sources of your inspiration matters. Now, the computational systems that we tend to build, if they are using semantic information at all, tend to lean much more heavily towards this intra-inspired way of life. And there's many reasons for this, but a big one is the fact that computers, as we all know, process features and parameters as numbers rather than semantic concepts. So one color is a field of values. One sound is another field of values. Less feeling, more quantitative thought. And we don't see the world this way. Our brains take in numbers and they're automatically mapping concepts to color and sound. We just make this big jump. So humans don't say, you know, gosh, this RGB value really hits the spot, unless you want to distance yourself from your audience. We say, wow, those eyes are the deepest blue I've ever seen. It reminds me of the ocean, and I'm going to go write a poem now about deep sea diving. We bounce from concept to concept to concept. We say, gosh, that music sounds like the time when I accidentally tripped at the county fair, and there went my red balloon drifting away. So these are ideas and they're stories that we can all connect with, and this kind of connection enhances the meaning of what we then go on to create. So the fact that we construct these mappings inherently is really an incredible gift that fortifies our strength as creative machines. But if computers aren't really built for this kind of reasoning, why should we even push them in this direction? Well, I claim that extra-inspired systems in particular are intriguing to pursue for at least two primary reasons. So first, if we can have systems that meaningfully and usefully map from one application domain to another, they might be able to connect with us better. And second, we can build systems that, if they are making these complex semantic connections, each system that we build can start learning from each other. So your system that generates paintings can then go on and inspire someone else's system that generates music. Cool. So now we have two big reasons to pursue this. Let's try to build one. Let's try to build an extra-inspired system. So for this paper, what I wanted to do was build an extra-inspired system that could meaningfully map salient concepts from text into ambient music. And the benefits of pursuing this kind of work include improved responsive audio when we're dealing with interactive playable media, in addition to new and useful and interesting sound generation for the visually impaired. So how might we work toward this kind of extra-inspired system and therefore toward these kinds of real-world applications? Well, when I built my system, I used this lightweight framework called Rensa, which lets us store and modify assertions about the world in a readable way. And it's useful in particular for building extra-inspired systems because it's founded in narrative understanding and it provides some handy functions. So, for example, it can extract some very simple things from text, such as what kind of entities we're talking about. Are we talking about firemen? Are we talking about dogs? Where are those entities located? Are they on a mountain? Are they in Canada? Also things like how are they described? Are they happy? Are they rainy? Are they simultaneously somehow happy and rainy? And then finally, what are those kinds of entities doing? Are they laughing? Are they walking? Are they giving someone something? So these kinds of things we can extract. And here's one example from the Python version of the framework just to show you kind of what using it looks like. So you can pass in a string, a story, or even just a sentence. So in this case, the cookies were on top of the refrigerator. And we just run a very simple command, and then Rensa will extract out the main ideas. So this is a format called Simprel, which sounds like a nice shampoo, but it's actually this format for expressing simple relations. So in this case, we have a left-hand concept that is cookies, and it's being related to the right-hand concept refrigerator by way of the relation location on top of. The tense of the sentence is also stored in case we want to re-realize the sentence into understandable English later. So this way we can extract concepts from text. We can also use Rensa to change those concepts. So in this case, the system is modifying how the extracted concepts are then realized into natural text. So we're starting with this example text input. Hermione laughs sadly. And using these kinds of basic concept extraction techniques, we're now able to extract ideas like the fact that Hermione is a female person. And that she's taking this action of laughing sadly. So we can do things like reword the realization. We can change parts of speech to obtain something closer to what a human might write when they're searching for sounds. We can also make substitutions. So based on the fact that we realize that Hermione is referring to a female person, we can now generalize Hermione to the word woman. And so this kind of a result makes for just a clearer search query that should obtain more relevant results. And if it doesn't, we can always fall back to the original phrase. I'm not showing it here, but these kinds of assertions also store time points as part of the standard representation. So if the temporal context in which the assertion occurred is important, we can specify that too. So now we have search queries that are developed by extracting this relational knowledge that exists in the text, and we can use those to request audio. So here is an overall simplified diagram of the system presented in the paper. Just like we talked about, it takes in a text input, it extracts the concepts, and then it uses these concepts to build search queries, which are then used to request sounds from audio libraries to build the final piece. So to ensure these kinds of clips are high quality, what we do is we ignore, or what I do is I ignore any sound clips that have a rating lower than 4 stars. I didn't mention also, but I also do things like append certain words to the query depending on what the concept is. So for example, sometimes the sound library that I used would have clips of people talking about the concepts that's being described, as opposed to a sound effect that's representing the concept itself. So there are rules that the system can use to avoid those kinds of scenarios, and this helps to ensure that the sounds we're using are more ambient and less like distracting speech. To determine a score for something like psychological novelty, what the system does is it examines its history for sounds and extracted concepts that it's been using for a given piece. So if either of these are similar to something that it's done before, it starts ranking those lower as time goes on. I am still working on a completed and full evaluation of how the system is critiquing its own work. But what I can show you is what kinds of music the system is generating at the moment. So if this works, it will play. So this is an example piece that was generated by querying the free sound audio library. And the story that it used to generate this was an excerpt from The Lion, the Witch, and the Wardrobe. So in particular, it's this passage where Lucy, the main character, is entering this wardrobe, and you can, she's going through this wardrobe, and she opens the door, and suddenly there's this beautiful fantasy world in front of her. So if you listen carefully, hopefully if the sound works, you can hear her sort of rummaging around the coats and the books and across the soft floorboards. And then finally she enters Narnia and she meets a very strange person there. example of what's kind of being produced by this kind of a system. Now, in terms of evaluation, there are many ways that we can assess this kind of a thing. First and foremost, it was critical for me to determine whether the system would be able to make a coherent mapping from text to audio as it pleased. So if a coherent translation was being made, the audience should be able to match the original music to the text. As a very small preliminary evaluation, what I did was I took two emotionally distinct texts, and I had my system generate musical pieces for each. I then divided my participants into two groups. So both groups read this text A, half listened to the music that was actually generated by text A, and the other half listened to a distinct piece, and then they were all asked to describe how well the music fit the text. So let's first talk about the group that listened to the music that matched the text. So a little less than half of them thought that the two paired well. And incidentally, a small percentage of them also suggested that the audio would be suitable for some kind of film adaptation of the text. And that's something that I didn't actually ask them about. I don't know if that's something that would increase or decrease depending on if I explicitly asked them outright. That was just something that they noted in their own comment box. So what about the group that listened to music that didn't match the text? Well, only about 12% thought that the two paired. The difference between these two groups was found to be statistically significant. And I ran some additional tests to determine if there were other factors that were contributing to their decisions here. So factors such as gender, whether they had read the text before, these kinds of things actually did not statistically affect the results, their decision ultimately. And then, but interestingly, if they commented about certain emotions that the text conveyed, so things like, oh, this musical piece sounds really serene to me, or it seems like in this piece that the main character is experiencing awe, that didn't affect their decision either, which is very intriguing, which it seems to suggest that participants are experiencing the musical piece. They can definitively tell you whether a certain piece is matching a text over another one, but they're disagreeing completely when asked the reasons why. Preliminary results do suggest that what they are picking up on are these semantic concepts. So if you read them a description of, say, the Slytherin common room in Harry Potter, they'll explicitly say, well, this music sounds like a Slytherin common room because I heard fire crackling and potions bubbling and something that sounded like a cave door entrance. So it thus appears that these kinds of semantic relations are being picked up, although I will have to do more evaluation to confirm those kinds of findings. I encountered a number of challenges when building and evaluating the system, and one of the big ones was that humans are very, very good at creating and understanding stories. Computers are not quite there. So disambiguating certain word meanings was not a priority of the system presented here. As one example, if you, say, told a story about a little house on a prairie, the system would say, oh, a house, I know what that is. People can live in houses, and then would go and try and retrieve sound files related to house or houses. But as some of you might know, the term house is also a musical genre. So, and the sound files aren't labeled as house musical genre, which is it's a kind of electronic music, by the way. They're tagged as house. So a better kind of system would be able to make that kind of distinction, perhaps even incorporating some kind of pre-listening feature to check out the sounds before using them. And that might be something that could be resolved potentially in the future, depending on feasibility. This leads into another limitation of the system, which is somewhat similar. So any human can really upload a sound file to an online library. The system here only looks at highly ranked sounds or highly rated sounds. Even then, it doesn't really guarantee the sound retrieved is of high quality. And even if the sound is a really good sound, if you combine it with another sound, the overall profile might completely change. And this system does not know how to deal with those kinds of issues yet. So to illustrate this kind of point, one of the sounds that my system used as part of the beta test was a sound effect that was supposed to represent falling snow, falling snowflakes. Only to my beta testers, it didn't sound like snow at all. It sounded like fire to them, which is almost the opposite of what snow is. So convincing sound design is hard, even for humans. beyond these kinds of limitations, where do we go from here? Well, in the future, I'm hoping to evaluate exactly how creative these generations are. I unfortunately only really got the chance to evaluate whether people could make connections between the text and the source text and the inspired piece. I'm also interested in what happens when we start blending these kinds of concepts together even more. So let's say I want to listen to some background ambience that sounds like I'm at Hogwarts in the Harry Potter universe, except I'm in outer space. So how reliably can we build a system that lets us do that? And finally, I'm interested in building more inspired systems, particularly extra inspired systems that can extract these commonly salient concepts from other media and incorporate it into their own creative work. And I'd also like to pose that as a challenge to everyone here. I think that's something that we can do, where this is a very inspiring community, and I'm just continually impressed by all the results that you're coming up with, and I'd like to see how you guys all inspire each other. I'm going to put up, so this is the link to the public version of the general framework, if you'd like to check it out. It unfortunately only has English support for now. I am working on other languages, and the main public repository is about a year behind the private research code. It should continue to be updated, and you're welcome to contact me if you want to have access to the private research versions. Those have more fun stuff like corpora. They have functions from converting from English sentences to first order logic and vice versa. Other than that, I'd love to hear your thoughts and questions.
Thank you for the talk, and that's a nice system. 3 years ago, I think, at ICCC, we presented a system called Audio Metaphor, which takes a sentence and give a soundscape composition.
Yes.
So I'm sure your system is a little bit more sophisticated, but so 3 quick question is, how does it compare? And we would love to compare it actually with the same query and see how the results compare. And my 2 other questions are, how do you get to music? We just did soundscape, but in your case, there's music, and you didn't mention much what you do with that. And the third one, which was the toughest one in our case, was how do you actually, because I believe your system is also polyphonic with more than one voice, how do you deal with audio mixing?
Okay, hopefully I'll remember all of that. So audio metaphor, yes, wonderful system. So I think the main distinction, and I could be mistaken, but I believe the main distinction between this system and audio metaphor is that this one is, instead of sort of, what audio metaphor does is it takes the text and it kind of makes these combinations of words. So it says like, okay, rainy day, fall Vancouver, and it says, okay, well that could also be rainy Vancouver, those kinds of things. This one, what it actually does is it goes in and tries to find those kinds of semantic relations in the text, and then also those semantic relations have to be ones that humans are picking up on as well. So it can't be just things like, beyond audio metaphor, a lot of the related work in this regard is more things like, we generated a song that, because this particular text had much shorter words than usual, we used a lot of staccato notes, sort of more surface level features. So audio metaphor is very impressive work, and it is very similar in this regard. Your second question was what?
Was going to music.
How do you use music? Okay, so in the paper, there's it talks a lot more about the music part. So essentially what this one does is it takes, so it goes out and takes those queries, goes to the audio libraries, retrieves sound files, and then in terms of combining them, it does a few different functions, like it kind of compares them and it says, okay, this one is pretty loud, so we're gonna mute it a bit so it will blend in with the others. That was a really key part of making it ambient and sound nice. There's a few other things that kind of mixing the sounds just to make sure that they are, that they blend together well, like that. Temporally, like the one you just heard, really we're not changing the temporal sequence at all. It's, this is the concept that was extracted from the text at point 1. This is the concept from point 2. So it's just going in order. And then what was your third question? Oh, okay, great. Thank you so much. That was lovely. I'm glad you brought up audio metaphor because that is an important piece of work.
So I have a question about evaluation. Your evaluations, you gave you some nice numbers, but I think there might be a problem with that particular evaluation technique. Did you have two separate groups of people that you were asking, or?
Yes.
Yeah. Okay. So and you were saying, does this remind you of that?
Yes.
Yeah? So you've basically told them what you're trying to find out, and that's usually something we try to avoid.
No, I didn't say, did this remind you? I said, do you think it matches or not?
Okay, so but you're still
is
trying.
that the same
You've told
kind
them
of
what you want to
problem?
know, effectively. So,
okay.
so there is. I'd like to suggest, if I may, that an alternative way, which might give you clearer results, which
good,
I think will actually be good, because it'll give you better numbers still.
Okay.
Is if you do a forced choice paradigm between different pieces of text. So you have one piece of music, and then you ask them to choose which text it goes with, and maybe you give them an option of none at all. Yeah?
Okay.
So if you do it that way, because you're sort of working backwards. I think it's a truer test of what you're trying to achieve, and I think my intuition says that you'll get better results if you do it that way.
That's wonderful.
Yeah,
Thank you
numbers,
so
I
much.
mean.
Yeah, I'll definitely pursue that. So add that onto the future work side. That's where I'll go next.
One last question.
All right. Oh, thank you for the talk. It was very interesting. I'm noticing it was kind of a big surprise for me to see more and more work like this come up, sometimes under different names. Just at EverMuseArt, we had a related talk under the name of cross-domain analogy, and recently I attended EverMuseArt, which also had this idea of taking something from one field and putting it into another field. And amazingly, I've been doing this as an assignment in my class, and of course, not the same depth as you reached, but students do smaller scale projects of this type. And what I'm trying to understand is kind of the big objectives of this type of work. I was wondering if you could comment on that more, and in particular, perhaps about combining intra and extra inspired systems, kind of merging them into one. So what would be like an incredible achievement in this direction?
Yeah, it's definitely a similar concept. So could you say the last part again? Just how you think that will go on to
one system that's both intra and
intra inspired versus extra inspired.
So simultaneously both.
Yeah, I think that's I think that's where the true power of this is going to be. Because once you start, the power of us is that we can combine all of these things together. So I certainly think that's where it's going to go. So do your students, what kinds of projects are you talking about, or what kinds of analogy?
I've done it in two classes so far, so it's been a total of about 30 projects. So converting audio to poems, poems to visuals. I mean, they've tried, of course, without the depth, because it's a shorter project, but they've tried very, very many combinations. Created really, I could show you, I collect them.
Oh yeah, I'd love to see.
Okay,
yeah.
sounds great.
Yeah, I think so what I was trying to pursue here is just, we haven't, as far as I can see, we haven't quite gotten to this point that we can really just, we have this set of concepts that humans are also picking up on, and we can consider this entire set and use that to inspire something new. So we don't really have systems at the moment that can completely understand story and what's going on underneath the surface, and using those to inspire its own work. And that's really what I was trying to press with the term inspired system. So I'm sure we'll talk more about that. But.
Yeah, so other questions in the break, I'm sure Sarah would welcome them. If we could thank Sarah and all our speakers, and that'll be the end of the session.
This paper comes from the former Metametrics group. And we're looking forward to an intriguing paper on cultural applications. Three cultural applications of games, fluid games. Over to you. I'll give you 10 minutes time.
Yep, thank you. Hi, I'm Sven. I'm from the UK, from a group called the Metamakers. We're part of the Falmouth University. And this paper is a collaboration of the entire group, as you can see with all the authors. So I'm the second one. So if there are any questions, I think I can answer most. Some of the questions I might stare blankly. That means you should have asked somebody of the other people. So the paper I'm presenting is on fluidic games. You've not heard the term before, or you've read one of our papers. It's a term which has been coined recently by Simon, and I'm presenting it in 3 cultural contexts. Why 3? It's 3 because we had 1.5 years' time, and that's as much as we could cram into that time. So what I'm talking about is first, what are fluidic games? So I'm giving a brief introduction to what we mean by that. Then I'm presenting the technology we developed, which is games tech, basically. And then I go into 3 applications. One is classroom usage and rapid game jams. Second one is an art installation. I create and you destroy. And the third one is basically the game itself. So what are fluidic games? So if you know the work of Kate Compton, fluidic games are some form of a casual creator. So they are not really an entire game, but they're not a design tool by itself. It's a mix of both, and it's the main purpose is it should be fun to interact with. So they're quick and easy, and more importantly, they're really, so the focus is on fun in the interaction when playing them. One thing which is important is that designing an entire game within the fluidic app should only take a couple of minutes, whereas normally game design, you do a degree, you spend X time, and you can basically, a game scales up from something you can do over a game jam to something where people invest 100-person years basically working on it if you scale it up to a AAA game. The games I'm talking about don't want to compete with any AAA game. These are casual games, so they're small, and most importantly, they work on mobile devices, and they're designed entirely on the mobile device, which is the novelty to that. So one of the purposes that new game dynamics can be developed on device while you're on the move, and it should enrich the sharing, application, and usage of the new game concept. So that was really abstract right now. I want to be a bit more specific. So in the context of computational creativity, fluidic games represent a subspace of game mechanics in which you navigate freely. So within the space of a game, you basically pick a point, and around the point you can entirely navigate within the app, which gives you tons of freedom, but it's also really complicated, which you will see in a second with the first app I'm presenting. And one of the points is that the exploration and design of new games is the key mechanic of the app itself. So the first prototype we've worked on, which is our in-house tool, is Scylla. These are 4 screenshots. So in the top left corner, you see tons of small cards. These are each individual games which have been designed in the app. And then you have tons of weird dialogues. That's one of the problems of Scylla, actually, which is why we're not giving it away to users, but use it in-house, because it's a 284 parametric space. So that's perfect if you give to a 4-year-old and say like, oh, you have 15 pages of a total of like nearly 300 sliders with I think, what was it last? 2.5 trillion different combinations of games you could produce, which is an impressive number, but doesn't help you if any of those are not fun because you don't reach any reasonable point. A key focus of Scylla was rapid switching of design and play. Because the parametric space is large, what you want to do is you change something, you want to explore it. By playing the game, go back in and go back out. But the interface is just unfiltered, which is not useful for what you'll see in a second. So the next app, this is basically the screenshot, is called Weather. If you're British, you don't find this funny. took me some time to get what the name stands for, because I'm not British. So the interesting bit is from Scylla, from the space, we basically picked a point, which is Let It Snow. It's a really tiny game you can find on the iOS App Store. And from that point, we basically expanded the space again, but in a way which is more concise and more contained. So you will find an iOS Fluidity game, which will be released soon, really soon. And it's a weather-themed app. This is why the name. And objects get blown around. It's a physics-based two-dimensional game. And it only has a 32 parametric space, which is way more concise, right? The thing is, we also put focus on that the navigation of the space is really centered around some really intuitive things, which I hopefully can show you in a couple of seconds or minutes. One key aspect which we focused on, which is still in there, it offers still rapid switching between design and play. Otherwise, you couldn't navigate the space. And also, the key point of the space exploration wouldn't be there anymore if it takes 5 minutes to load a new game, because then you don't switch between parameters that often. As a computational aspect, we have an inspiration button in there, which is an auto-generator. The auto-generator takes 2 games, or the chromosome representation of 2 games, does a crossover, and a mutation on a single point or multiple points. It depends on which version of the app you basically have, and creates you and shows you an entirely novel game. I'm coming to the point why this is really interesting in a second. I'm just always postponing stuff, but this is basically one of the key applications. So because we have an app where you can rapidly switch between gaming and playing, we started off with proposing rapid game jams. So if you've taken part in a game jam, normally it's 42 to 72 hours or longer. But you've probably not done a 10-minute game jam in a digital game. And that's one of the things we're proposing. So with the app, because it's really concise, you can do 10-minute game jams, which means you get the app, if you know the app, otherwise 10 minutes don't work. And you basically can start designing an entirely new game based on some motivation, what you want to do within a couple of minutes. So Simon, because he's really quick with his hands on his iPhone, can design a game in 1 minute. For me, it takes roughly 10. Because then it stops. So we did a couple of game jams with a local organization, which is the Cornish Girl Guides. And we had 104 kids aged 4 to 14 participate in the game jams. The interesting bit, it's 4 to 14, which is super young. I would say the 4 to 7-year-olds barely are able to read. And you give them the app and you get some really interesting feedback, because if you give any iPad to somebody who's 30, 40, 50, they look at the iPad and just like, oh shit, what do I do now? Just pressing buttons, reading tons of text. You give a 4-year-old the iPad, and they start just grabbing away and punching all different things and explore the space way more openly, because they're not bound by basic education and everything else. I'm not proposing that we should stop education, but it's really interesting to see. It's just something which is super interesting to observe. And we had them design games, and then we basically, one of the points we're presenting in the paper is, we went in and categorized the games which came out of the first usage. And we could see that some key dynamics, because it's a small 2-dimensional physics-based game, some core mechanics basically always emerge. It's really dominant because they're super easy to represent within the app. But some others are really, really underrepresented. So for the 4-year-olds, for example, fast reaction-based games are not something they're super keen on. Most 4-year-olds are really keen on games where basically you always win within a second of play. So they start, everything loads up. They press one thing, they say, yeah, reward. But the interesting thing is, then they go in and change, make the game, so once they start exploring the space, they basically get more aware of the dynamics, make it slightly harder, slightly different, change it, and then share it. And that's one thing we want to focus on. So the game jams are something which is really interesting, because when we started the research or developing the app, we just did in-house testing, which is it's basically giving the game to a bunch of you guys or us, and then getting feedback. But giving an app or giving research to kids gives you entirely new feedback, which is really interesting. So that's one thing. If you can test your stuff with the actual end users of something, what you want to do, you get so much more feedback. Some of it is really unproductive, but some is really good. And that's something we still want to continue. So we were doing more game jams, and this also gives us tons of feedback on the usage of the app. Another thing we did in parallel to the game jams is we were asked by a school to foster creativity, which we heard in the opening talk today. And we went to the school. So this is a local school for gifted children, and they have a super cool school. I wish I would have had such a school. So everything is centered around fostering their individual expression, and they learn, and they can write on the walls. I would have just been slapped for writing on walls, but it's really fun. And we did 2 sessions to basically scope what is capable, of what we could do. Then we did a local workshop with multiple groups. We had 70 kids roughly from the school over the entire day, which came into a lab. We gave them 20 iPads. They brought 20 along, so they had 40, which is great. And then they basically designed for the entire day. What we did as a follow-up, and which we're still working on, is we developed a curriculum. That sounds overly complicated. It's basically we gave them a way to guide the exploration of the app in a more directed way, in a way we thought was helpful. And we did this because even if you give an app which basically has no text or is really intuitive, nothing is really intuitive, and it doesn't help. So we gave them some form of a meaningful exploration of that space by presenting them with challenges for exploring physics and exploring gravity, which the app basically offers. And these are some findings. These are all significant findings which we're presenting in another paper, which is currently under submission. And these are some of the things we found in the study. So there's the inspiration button, which I'm showing in a second. If people use it, they found it helpful. We had tons of people who absolutely did not want computational feedback generator basically as part of the app, but the people who used it and who found that they could basically explore the design space in a way which they were not aware of, they found it really helpful, which is interesting. There's a negative correlation or significant negative correlation between the interest in a design in a game design carrier and the usage of a clean slate. Oh, shut. For all those, just read the paper. No, the interesting part to take away is that game design people or kids were roughly 14 to 11, which were interested in pursuing a career as game designers, didn't like using the clean slate, which basically didn't like to start off with an entirely empty game. And they also didn't like using the app that much because they felt they were more creative doing something else, because most of them already played tons of other games. The young kids, aged 4 to 11, basically, they had less exposure to existing games, and they felt that it was more interesting and also more creative. The last part I'm presenting, before I hopefully can start the demo, is an art installation which we did. So we did an art exhibit where we invited tons of artists relating to games to present their artwork. The exhibition was called Games as Arts, Arts as Games. It was held in the lovely Falmouth in October last year. So we have people from game companies presenting their artwork. You see sketches of, I think that's Luminosity, and we had exhibitions from Botanicular and other games, and that's basically what we presented. So we presented a version of our game engine or of our game design tool, which was auto-playing. So we had the AI play and create new games and basically be in a constant cycle without the user. And the only user interaction we allowed was when the user tapped on the display, it killed the game, and then a slogan came up, which is, I create, you destroy. And that's basically was an argument against the constant negative signaling you get when you read Daily Mail and other things when it comes to AI, that AI is always the bad thing which we shouldn't pursue, because it's not that simple. So AI is not colored, it's we who color AI. And it's the same here. So if you tap the screen, you kill the game. So you take basically away the creative freedom of the app in some sort. It's an art installation. So it's not, and it's, yeah, I should stop. But it was really fun seeing people standing in front for 10 minutes, just seeing when games pop up, and then they tapped it and it's like, I create, you destroy. And they was just like, and then they turned around and left. And some were basically, which is what happens for me, but some people were standing there and constantly killing off the games for, like, I don't know. But that's what's really interesting. So I could have just standing there and just observed what they did. So one thing I want to try before the microphone's taken away is, that's the website. So if you want to see further information of the game, it's a really beautiful website. The app will be up soon. But the main thing is, this is actually the app. So that's a live demo, hopefully. Yeah, it is. So it's an iOS app. So we have tons of different games included. I think we ship it with roughly like 50 different games pre-designed. These are not auto-generated. These are hand-authored. The interesting bit is you go into one. Which one do I take? I should take this one. And this is basically a representation of the genome. So you see all information relating to the entire game on that screen. You can click on any of those and change any of the things. And down at the bottom, you see the play button. So what I do is I start playing now. Then a help thing shows up. And the thing is, this is basically, I hope you can see that, I'm controlling with my finger the spaceship, and then I died. Yeah, that always happens on demonstrations. But one thing I can do is I can basically go in and change the rules of the game. So what I do is I go now in and say, like, I don't want the stars coming up from the top. They should come up from the side. The other things also should come from the side. I don't want any score on that. And the other thing I'll do is I want to change the controller. So what you see now is something we show in the video. So I changed basically the type of game from a top to bottom to a side scroller. And that's just one of the easy things you can do. Yeah, and I died again because I'm just demonstrating it now. Again, just to give you another example of a really quick game. So one thing I have two devices with me. So if you want to, after the panel, not before the panel, you can find me and I can give you a device and you can just explore the app yourself. One quick game is, because that's really simple, is Keepy. Oh shit, I changed it. So it's Keepy Uppy. And what I did is, because it's constant change in play, I went in and I made the actual controller way too big, so it's constantly crashing. So it's basically, I control the ball, the alien head, and I need to bounce. I shouldn't have done a demo. I should have just shown the video where I really well play. And you can go out and in and change the rules of the game. This is basically how you control the scoring. And the app offers a really nice way of going back and forth. And that's one thing we're currently working on, because I didn't show any generative component, which I'll do in a second. So you go back out and you say, like, yeah, that's all fine. I want a new game. And it goes back in, takes two existing games from the library, does a crossover and presents you a new game. This game is not always playable and not always winnable. That's one of the interesting bits. It's just a novel point in the game space. What we're working on is optimizing that the result is most of the times playable and winnable, with a switch to turn that off and on. Because that's one of the interesting things in game spaces. You don't always need to have a game where you can actually win. Sometimes you want something which you can repair, so that the people basically engage more with this. And this is also what we're trying to put in the curriculum. And my time is up. Thank you. If you want to play around,
Okay, So think carefully before you ask the question. We're making it up as we go. That's fluid. Anyone got a question? Sorry, tempted.
Thank you for your great presentation. I really like the way you're going with your work, and we've been trying also to work with tools that we experiment and provide to kids so they can actually work with them in what we think will be a more creative context. And one thing I would like to ask you, which is something that we also stumbled upon, is that when there is very little time for the interaction, and did you let me ask you this another way: did you show the result of kids' creation to experts, game designers?
Yes and no. So a lot of the games the kids produced were not super great, and they were just, and that's one of the things. So sometimes the design process itself is the fun part. The games we categorized, so we categorized 100 games, which meant I had, and with other people, had to play 30 games in a row to see if they're fun and if they're engaging and enjoyable. And that's one of the things which we also gave to a couple of game designers at Falmouth University. Some of the games are really interesting, and they basically came up with entirely new mechanics, which we haven't seen so far. But most of it is also what the graph showed. It's basically the same thing. So they went in and as a first step, reskinned, changed it a bit and tweaked it to their needs. So yes, we gave it to game designers and showed it to them. They were mostly not super impressed with the results, but it was a nice starting point for them to basically then go in and design games themselves, just within the app.
This is kind of what we also get como result. In our case, we work with the stop motion application. So the kids will use this application to create some kind of stop motion movie. And what we notice is that the result then we show to a professional and academic from the animation and movie, more animation, and we got exactly the same results. So they were not able to distinguish or shows, what they would classify as creative in the context of their jury and their festivals, but the process actually transformed the kids.
Yeah. One interesting thing is, so most of the game jams and the data we did, the game jams were just 90 minutes. We had a longitudinal session, which we sadly didn't record, and the kids were basically using one of the apps, which I also have with me, which is called No Second Chance. And they were using this app for a longer period of time. And what we could see that some of the games from some of the really engaged kids were really good, and they were really interesting. But yeah, but it's the same. If you look at regular games, if you go on Steam and look at the Steam Workshop add-ons for some of the games, they're also not really good. So the process is one thing which is really interesting, and that helped some of the kids, and they found it really engaging. But it's the same with all games. Some are not really great. But if the process is fun, that's more important, at least for us right now.
Got time for some more questions on this side of the room? I'll get that to you later.
Have you thought about how you could automate the evaluation of novelty for these games? What's meaningful novelty for one of these play experiences?
Yes. So because each game is represented as a genome, there are different ways of identifying novelty. Novelty could, that's one of the really difficult things, because a genome doesn't actually capture all the mechanics which are there. And this is one thing we investigated, but haven't found any publishable good results yet. Because the mapping of genome changes towards mechanical changes is not, it's not a one-to-one mapping. There are a couple of genes which are required for a change, and we haven't yet identified anything which is worthwhile putting in the app. So.
Thanks. I would just follow up by saying, in general, don't try to evaluate meaningful novelty in the genotype space.
Yeah, but the thing is, evaluation, and that's one of the downsides. So one of the things is, which we thought about, which we did something similar offline. So we basically took the resulting games and tested them on a Mac, so on our servers. And that's something we can do. But one thing this entire infrastructure lives on, and that you can do everything, like the evaluation of a game and showing if it's new on the device. And with the current environment and current hardware, we can't run any simulation whatsoever. So the evaluation which we wanted to do on device is not possible. We did something offline, which we took genomes, ran them in the simulation, and then basically evaluated the games. But we couldn't do that on device, so yes and no. But yeah, from the genome itself, it's really hard. And currently we haven't seen anything which pops up, which works.
Okay, we've got time for one quick question from Ollie.
Thanks. Yeah, great talk. It's actually very related to Kaz's question. You came up with your own list of the game types, like Keep It Up and and herding and all of these things. Have you got a sense of if that's extensive, if that is exhaustive over the space? Does it relate to any other literature in that game space, or did you try and crowdsource that kind of analysis? I'm just curious whether that was just off the top of your heads, or whether, and that obviously relates to the question of whether you might be able to do a transformational creativity move within that space, if that makes any sense, which maybe it doesn't.
So, the current analysis which we present in the paper is on top of our head. We haven't crowdsourced any of that because we currently don't have the app available so that people can actually basically test that. We initially thought the space was way more restrictive than it initially is. So we thought that it wasn't 10 categories. We thought it was like 4 different game types when we started. But what we saw is when we tested it with kids, that they basically came up with a couple of things which we couldn't fit in any of the categories. That's one of the things which we're working on once the app is live, that we basically want to investigate and crowdsource and see how that works when basically when we present games within the app to different users, how they respond to that. And we might basically have an evaluation feature in there eventually. But yeah, that's not been done yet. And this is just us investigating. So it's 10 pairs of eyes analyzing 100 games and just categorizing within that 10 and then basically just evaluating if that fits. But yeah.
Thank you. And let's thank the speaker. Okay, in the next and last talk of this mini session before the panel, asked some pertinent questions about visibility principle and design. It was by Liam Bray, Ollie Bond, and Benjamin Carey. And over to you.
Thanks. That's your son. Hi, everyone. How's it going? So yeah, I'm Liam from the University of New South Wales. I realize it doesn't say up there, in Sydney. And so far I've really enjoyed seeing all the guts of all the systems that have been developed this year. And I particularly enjoyed the workshop that we had at the beginning of this week, Mumi, where we got to see a lot of musical type interfaces be developed in the computationally creative environment. But today I want to talk to you guys about visibility. So a design principle which I've been focused on and thinking about. And I think that it's an interesting thing for this community to think about. And I think it's an interesting topic for us to all engage with as designers, even though some of us might not self-identify as designers. We're in the business of making software, hopefully, and sometimes not, for the use of other people. So we'll start off by just talking about categorization that we've developed, and then we'll discuss several of the systems that we looked at, and then we'll have a look at a expert user who we spoke to about his use of these kinds of systems in his practice as a musician and composer. So starting out, I'm talking about Norman's principle of perceived visibility, which is the simple idea that the more visible the operations of a system are, the more likely users will know what to do next. It's a principle that's used a lot in interaction design, and we use visibility to describe those tangible aspects of an interface, which provide the user with immediate feedback about what they're doing with the system. Computational creativity is uniquely positioned in the sense that it deals primarily with very, very complex systems. And that means that it engages with these interaction design principles in its own unique way. And that often means that in a computationally creative process, the aspects of that process are hidden from the user. This could be because of efficiency. This could be for clarity. This could just be because it's completely unmanageable to show them the inner workings of these systems. But this can often and sometimes lead to a black box kind of scenario where the user sees some kind of input, they provide an input to a system, the system does something with that information and provides the user with some kind of output. But the extent or the nature of what's happened in between is not necessarily visible to the user. It can be hard for them to understand. And I think computationally creative systems often fall into this pattern of interaction. As the visibility of systems often scales with their complexity, the more simple a system is, and I'll show an example of this in a second, the easier it is often for a user to understand exactly what's happening. But the more complex it gets, it effectively leads to a decrease in their capacity to be able to make intelligible decisions on the system. And we can think of readily available examples of that. A simple one that I often use as an example of this is that if we have a 2D physical model, we have an agent moving around in that space. If we have a single agent moving in that space, you can expect someone to be able to map this quite easily. It's a relatively simple thing to follow a ball moving around in a simulation of gravity or something like that. But as soon as we introduce more than one or two, or we get 4 or 6 agents interacting in that same environment, we often end up at a point in time where the conceptual model of exactly what's happening is no longer tangible to the user. They can no longer have a clear conceptual model of what's going to happen in that system. So an example of that would be a paper that we talked about last year, which had an example in it, which is this. Nodal is a generative music composition system, and it can create simple or complex systems, networks of events. And this is an example of a very simple one. Sorry, there's no sound. But it can also create sufficiently complex systems. And this is kind of where my thinking around visibility lies. This system is very hard to conceptualize as a user. Making intelligible actions in this system, making some kind of discernible action on what this system will do next, takes on a different form. It becomes structural. It moves away from the immediate, direct manipulations that we see in a simple system and becomes something else, something where we take on a more curatorial role. And we've heard that said a couple times throughout this week so far. So that leads us to start thinking about what we might want to do about this problem, what we want to think about, how we could investigate what this problem, how to solve this problem, potentially. Yeah, the fundamental thing we've arrived at is that if interaction design best practice tells us that visibility is fundamental to the intelligibility of a system, how can we design interfaces that make sense of computationally creative processes in a highly visible way? And we want to incorporate these tried and true design principles into the design of our computationally creative systems, because interaction designers have done this work. They do this work daily. They create software and they think about how to evaluate that software in accordance with certain kinds of principles which afford users a better understandable interface. And so I think it's also obvious here that there's a caveat to this, and that is that visibility or encapsulation of systems doesn't inherently inhibit usability in CC systems. We can all think of ways in which encapsulating the system or hiding the complexity from a user actually helps them to use the system. But it's our observation that specifically in creative tasks and music compositional tasks, here is what we're looking at, a user is able to make more intelligible actions when they have a structural knowledge of what the system's process actually is, when they can begin to understand exactly how the system is functioning at a slightly lower level. And this contributes to a positive kind of effort to benefit relationship when they can begin to visualize this. I'll use this analogy, which Blackwell has, which I'm lifting from Blackwell, which is that if we consider creativity support tools here as distinct from productivity support tools, I'm just referring back to that, that Blackwell proposes that for tasks that have potential to be automated for users, users have to weigh up the cognitive effort or the amount of risk, the amount of time that is, it could be, associated with setting up an automated approach to the task. And he would describe that as prospecting, as in digging a hole in the ground to find out whether it's worth seeding a gold mine, is the analogy. And in co-creative systems, I feel, and it's my feeling at the moment in this research that we've kind of arrived at, is that computationally creative systems often take on a different kind of form. And as I said, this is what I might describe as like the role of the curator or the editor, which is a kind of a more structural approach to the control of the system. And I don't think it necessarily fits so neatly into these kinds of paradigms, the productivity through automation. And the question that I have here is that our users, when they approach using computationally creative systems, are they actually approaching this kind of problem? How much effort or risk is associated with me completing a kind of a task in this system? Are they actually evaluating that before they start working with these systems? Because in my own personal practice in creating music with generative or computationally creative systems, I don't find that's actually the way that I approached using these tools. I think instead, I actually, in doing a creative task, I first I ignore the efficiency of the tool, and I'm much more inclined to think about how it might enable me creatively in a creative search kind of sense. Whether this be undirected creative search or directed creative search, I find that that's much more the way that I would approach using one of these tools. And I'm not so much worried about the benefit or efficacy. And a third concept that we're drawing on here as well is this idea of an abstraction gradient. And that would describe the fluid state that the system might be in. So I think it's fair to say as well that systems that we're designing have many different states. And at different states, we can place them on different levels of abstraction. The system might remain very abstracted for some of the time, but allow you to have access to much lower levels of it. And this is, we're all familiar to doing these kinds of things. When we think about general purpose programming, we can think about encapsulating things and going back into those functions or classes and things and editing them and things like that. This is my attempt to visualize that. I understand this, I don't understand this. To this end, we in our paper have decided to try to divide up, in a way, the different kinds of systems that computationally creative designers might come across when they're thinking about representing their process. And those three systems would be direct manipulation systems, which are systems in which a user with an immediate representation, immediate representation of objects and interest, can manipulate with immediate effect, programmable interfaces, notational interface, which allows the user to define a set of control commands to be executed as a program. Objects may be represented directly or encapsulated in this process. So this is this kind of dynamic system which can move quite fluidly. And highly encapsulated systems, systems in which the representation of the process is wholly encapsulated. Users are presented with parameterized abstract control of the system, which is hidden from the underlying processes. And so we think these categorizations fit across the spectrum of an abstraction gradient. Yes, anyway, so to the point. We conducted a practice-centered evaluation of computationally creative music composition systems, a mouthful. And we, drawing on the practice-based research approach that you find in many creative task research domains. And we're interested in asking the end user, someone who uses these tools in practice, what their experience of using these tools is. And using that as a primary source of knowledge for us to feed back into the design process as computationally creative designers. So our end user was the third author on our paper. As he is the primary source of knowledge, we thought that that is certainly worthy of being one of the contributing members of this paper. So Benjamin Carey is a Sydney-based saxophonist and composer and technologist. He has interest in contemporary classical and interactive improvised electroacoustic music. So he is someone who has a close relationship with these kinds of tools. He uses them in his daily practices and teaches them as well. And so drawing on that, we evaluated 3 different tools. Those 3 different tools are PATA, a stochastic event generator, which generates segments of MIDI events based on these mean and deviation weightings. Yana Live, which is a Markov model system, which has a very similar, as we saw previously, a call and response kind of interaction with users. And Style Machine Lite, which is a corpus-based event generator, which populates Ableton Live's clip view with an entire sequence of clips, including a kind of a broader narrative as well, a song structure. So we gave these 3 tools to Ben, and we asked him what he thought about each one of these tools. This was his first time using each one of these tools, and we gave him an open-ended task. We said, tell us as an expert, what do you think about these tools? What do you think about them, and can you use them? So we asked him several questions. We asked him things like, do you feel you had control over the tool? And how often do you think the system proposed interesting results? Or how would you describe your approach to working with the system? I was particularly interested in this to see if computationally creative processes augment existing workflows that people have. Do you trust the tool to make musical suggestions? Another question, a very interesting question to ask someone. And what functionality did the system provide? We came up with all kinds of different results. I'm not sure if we came to a complete conclusion about exactly what the way that he approached using these systems or exactly what his understanding of it was, but we did gain some very interesting things, very interesting pieces of insight. And that is that, and I'll try and skip ahead a little bit here because I realize time is short, that he articulated something that we had already kind of assumed. We had thought about this as ourselves as practitioners. That in a computationally creative system, if you provide someone with endless parameters, as in something as complex as a Markov model, that becomes daunting. And it becomes difficult to manage as a creative practitioner. It also simultaneously allowed the user, the person using it, to create endless variations, which was a very positive thing and something that a lot of our systems are capable of doing, facilitating this kind of variation generation. But he found that this was at the loss of a kind of a sense of agency over what was happening with the system. And this is the primary kind of articulation that came out of this, that he was simultaneously needed to have this kind of structural control of the system to use this system that had endless variations. But at the same time, he also felt removed from that as the user. He felt removed from his sense of agency. So I think that is really something that we have to continue to wrestle with. And I'm not sure that we necessarily have a direct answer to that. So this is his, I've got to finish up. But yes, I felt passive as it is difficult to see the real connection between these choices of material and the output, though this may change over time. Something I don't have time to address, but that is a very good point as well. So our conclusion is essentially, I think we have lots of interesting challenges that are uniquely focused at us as designers of computationally creative systems. And I think that we need to think and articulate exactly how we can respond to things like the core principles that interaction design provides us, and reflect on how we might be able to create more tangible interfaces for users, so that we can address things like the complexity problem that we have with visibility, with the goal of trying to create more usable interfaces for people to use computationally creative processes. Our goal with this categorization is to provide a framework for people to begin to think about where their system might lie, and when they create an interface for their system, what that might actually mean for interpreting that information. All right, thanks.
Okay, we have some questions from you, or I mean, I'll start here with mine.
Thank you very much for the talk. That's actually very timely for me. I just started designing an interface.
Oh, great, we should talk.
It was really great. Yeah, so I was curious what to think about a fairly standard approach where the main interface, when you just look at it, is very simple for a basic or novel user. But then, you know, you click an advanced button and suddenly you have all these controls.
Yes. Yeah, I think that that kind of system is what I'm trying to get at when we say, I'm just trying to flick back to the right slide, what we mean by a programmable interface. And that it could slip between this direct manipulation system, something where you have an idea of exactly what you're doing, and then a programmable interface. But if you're doing something like encapsulating your entire process down to a very simple thing where maybe you've got 2 or 3 buttons, then yeah, that's certainly a highly encapsulated system is what I would describe that as. But what I think about that is, I think that approach, having a kind of a loosely defined interface, one that's malleable for specific kinds of interactions, I suspect is probably one of the best ways to do this. I mean, that's my suspicion. And I think that, yeah, definitely we should try and investigate what it would mean to represent, depending on which type of process, but what it would mean to represent it at computationally creative processes at different levels, and how far we can take that analogy up and down.
It's a really important topic to have designers and UX being applied on how computationally creative systems are going to eventually meet their audience.
Hopefully.
But I have a comment and a question. The comment is, and that might be a question too, is the visibility principle in UX design is not about the visibility of the process. It's about the visibility of the interaction. So the elements that are interactive should be highly visible.
Yes, yes.
I might be wrong, but
no, absolutely, yes.
So I think what you mean by visibility here is not the principle of AG. It's a different. It might be something different. And then my question is, don't you think that there's a moment where there's a threshold where encapsulating the process and actually not giving access is a good thing? I'll take an example different from the style machine, Prisma, which works on deep learning. They can't give you access to the process. Even the programmers don't really know exactly how those network works.
Yeah, no, definitely. I absolutely agree. And I'm not trying to make the point that encapsulating information or interactions is fundamentally a bad thing. I'm saying that it's state dependent. It depends on what is happening and when. And just designing interfaces which are just a blunt instrument, just completely flattening a display so it just becomes nothing but a few buttons, could lead to these kinds of interactions that we see in computationally creative systems, which is that there's just no way of understanding what's happening. You see some kind of input and just something happens, and then there's an output. So I guess what I want to do is make the case for designing interfaces which are more flexible. And maybe that has something to do with specialization. Maybe that has something to do with the layers kind of thing. But yeah, definitely. Yeah. Oh, and as for visibility, I think that there is an argument to be made that visibility also represents, because of mapping, a process as well. And that there's a relationship between the visibility of the actual the event you're interacting with, and the process that it's connected to. And that's part of what we do when we conceptually map or model ourselves an interface. we actually build a cognitive understanding of exactly what the knob is doing and how that knob is interacting with whatever the process might be. But yeah, something more to unpack for sure. Yeah.
Thanks for that talk. I thought that was really interesting, especially because you reevaluate these design principles in computational creativity and therefore also work on the idiosyncrasies of our applications. And from observing the work of my colleague artists, I often see that they try to explore the limitations of these systems, which I find quite interesting. So my question is, how could you make the limits of these systems visible? Because I think that would be very interesting.
Sure,
so people can go to these limits and probably cross these limits by certain means.
Yeah, I think that's a great point, and it's something that's definitely, I think, would be an interesting thing to think about, how you could visualize the limits of these systems. I guess when the limits are known, then obviously we're capable of creating kinds of representations which have very simple metaphorical applications where you have, smalls and bigs and things like that, and you move along these kinds of lines. But I think the problem that we have when we're dealing with like algorithmic control is that often the limits of the system are such a large search space that it becomes very unwieldy. And I think that that's just the core kind of the natural state that these algorithmic processes will have. So I guess my answer is I don't really know, but we definitely have to think about it. It's definitely something we have to at least acknowledge. Yeah.
Okay, thank you, Liam. Let's thank our speakers. Okay, next we have our panel. Alison and Anna asked me to whip you up into a feeding frenzy for the speakers. So we're going to use the Shark Tank as a model. You see the TV show. Our speakers will come down here and face you, and you are just to shred them with questions. Okay?
Right. Is that how it works in the Shark Tank?
When it works well, it works like that. We're going to hear from the speakers in a moment. While they're setting up, let me draw your attention to the fact that we have some cool new logos in the Association of Competition. Yeah. Okay, let's just thank, I think it was Hamilcar who arranged, and Raphael who arranged for these logos to be created by Portuguese and Dan and Carlos. It was a group effort. Everyone was involved in generating and they are variable. You will notice that this one looks like a donut. Charlotte, there's a more adult, you see more like a coffee area. And I think it leads us into this topic quite nicely, because we get to see design as the principle of interaction of aesthetics and functionality. As one of the speakers mentioned, we all do design in some way. Most of us are amateurs when it comes to design, and we have some relative professionals to talk to us today about design. Or at least they will talk to each other. We may listen to them and feel privileged. Okay, guys. We're about to start. Well, you've already started. We're starting now?
Okay, good. So I'm going to go first. It's not totally clear what we're supposed to be talking about, but something with design and CC was the charge, although there were about 8 questions that we couldn't possibly answer in the time, or at all, probably. So let me try to set the stage and talk about design in general. And a big question is what counts as design. We'll come back to that. For me, typically there are needs which turn into requirements, which turns into some kind of designing activity, some kind of result, and the result is a description. Coupled with all of that, the kinds of requirements you might have could vary a lot. There might be structure given, there might be behavior given, there might be function given, there might be all sorts of other things about the result, including things like how usable it is and so on. Another point to make is that we need to distinguish for creative design between little c and big C. I'm sure you know about this thing. We tend to think about very small creative acts as being not very interesting, but if you have something quite complicated like a design, typically they are interesting. Big C, good luck building the program. Myself and Kaz, to a certain extent, are interested in engineering design, where the product is key and not so much the process. So we're interested in evaluating the creativity. I'm interested in evaluating the creativity associated with a particular product. How you evaluate it is another matter. Typically, though, it's assessed by some observer. It might be a user, it might be an expert reviewer, it might be the designer, him or herself. It could be done when the thing is complete, or it could be done during the designing process. During is harder. It's all much harder if you're talking about a computational system that does both the designing and the subsequent assessment of the level of creativity being shown. There's a huge amount of opportunity for computational creativity and design. And I think we'll hear a variety of different approaches and thoughts about that. Most of the opportunities are because reasonable designs are complicated. There are a variety of design tasks and subtasks that people and systems go through. For example, configuration might be part of the process where you take known things and build relationships between them. Those could be abstract relationships, they might be abstract things, they might be concrete relationships, they might be concrete things. It's a whole bunch of different kinds of subtasks, all of which themselves provide opportunities for adding to the creativity of the resulting product, adding to the assessment of creativity. There are lots of inputs in the whole process. Requirements, of course, various kinds of constraints, because we're talking about physical things typically, but not always, various kinds of laws, what knowledge is available, and then the potential users and the potential uses all play a part. I think it's possible, an extreme point of view, to talk about routine design creativity, the little c version, and in fact, I wrote a paper about this to see what kinds of small changes one might make to end up with a product which could then be assessed as creative. And there are lots and lots of opportunities. A question raised by the constitution of this panel is whether a piece of music, a description of music is a design, whether a description of a game, i.e. a program, or literally a description, is a design, whether a recipe is a design. I think they probably all are, and so the designing of both descriptions is worthy of thinking about. I've been interested in, just to wrap up here, I've been interested in computational evaluation of designs, of the results. What kinds of evaluations can you make? And I've looked at novelty, I've looked at surprise, as says Kaz, and it turns out that a lot of the things that you would use to evaluate real designs with people doing it are very hard to actually make computational. So a study of that turns out to be much harder than you might think. So lots of opportunities. That's a little sort of introductory sketch. Pass it over to Kaz.
So I really wanted to start by saying that design is, if anything, at least an obnoxiously overloaded term, just like creativity is, right? I mean, bridges are designed and restaurant interiors are designed and winter coats are designed and airplanes are designed. And it's really hard to think of any kind of general purpose process that could apply across all those different domains, even when we all agree that we're in some way doing something similar. That's pretty familiar to those of us who are working in creativity. It's very difficult to think about how mathematical creativity and let's say abstract art creativity stem from the same process, even though we know they came out of the same kind of meat sack. And So I want to talk a little bit about some of the similarities and some of the differences really briefly about design and creativity. Some of the biggest similarities to me come from how people have tried to define the difference between what is and what isn't creative in and outside of design. So in design, we have this concept of routine design. That is, if you're designing something that there is very little or no creativity in. People have tried to define the difference between that and creative design in ways that would seem familiar to this community. People have talked about something is routine if you can fully enumerate the space of possibilities and you have a plan for how to search it. People have talked about how routine design is when you don't need to add any variables, when you don't need to explore any new ranges of those variables, so you have a fixed design representation. And those things sound a lot like exploratory versus transformational creativity and things like that. So there's clearly like a lot of similarity in the space that we're working in. Although one really key difference to me is that there's kind of a rich tradition of cognitive investigation of the process that designers follow. The process of designing seems to be more fair game for empirical investigation than the artistic process seems to be. And there has been a lot of work, some good, some also there, in trying to empirically study that process. And so that gives us way too many things to talk about that I can fit into this 3 minutes, but it lets us say things that, design is iterative. It tends to move from the conceptual to the detailed. It tends to start with functions and requirements and move on to behaviors and then structures. And we can also talk about how that process changes between different people. We can talk about how the processes of novice designers differ from the processes of experts, and that gives us some really interesting insights into the creative process. It also lets us, and I'll finish here, it lets us identify positive patterns and anti-patterns that seem to correlate with higher or lower creativity. Some of the things being identified as positive patterns is the capacity to surprise yourself with the representations of designs that you produce. You sketch something out and you go, oh, wow, I didn't see this, but I'll look into it further. And some things that have been identified as anti-patterns are prematurely fixating on an idea before having fully explored the space. And I think while those things were certainly established in design as being particularly good or particularly bad parts of the process, they really do apply maybe to non-design creative acts. And so I hope today we can explore some of those things a little.
Thank you. Hi, everyone. So I am both a game designer and a computational creativity researcher, and sometimes these things overlap and sometimes these things do not in my practice and my research. So I wanted to take a little bit of time to talk about how I approach game design as a designer, and maybe let connections to computational creativity emerge as they do. One thing that's really struck me listening to Kaz and Dave so far is they've both talked about design as sort of being requirements first, or like specification first. And in my practice as a designer and in the way that I teach about design, that's not actually how I think about design. I think I may be a different kind of designer than you guys are, which is fine. And that's one of the things to think about, right, is that design means different things to different people. I also tend to be very heavily process oriented. So I have like some scattered bullet points written down. So let's just pick one. So I guess the thing that I start with when I start with design, and the thing I try to get my students to start with now, is this idea of value-based design. And this is largely coming from the work of scholars and designers like Mary Flanagan, who's a game designer, where we think about what are the values that we want to imbue into the thing that we are creating? Is this a game that is about peace? Is it a game that's about love? Is it a game that's about conflict? Is it a game that's about, I don't know, like pick a value, right? Like we can make a game about it. And I try to think about how those values get infused into every element of the design work that's being done. So these values go into how we think about color palettes for art. They go into how we think about game mechanics. If I'm making a game that I want to be about about love, right? As like the super generic value, right? Then I probably don't want my mechanics to be very like contentious. I probably want mechanics to be about connection and belonging and sort of elements that are related to that. And so these values tend to infuse everything that I think about in the design work that I do. One of the fun things about being a game designer, aside from the fact that we get to play games a lot, is that what we're doing, and I think this is where I try to tie it into my sense of computational creativity, is what we're doing is what I've heard described as a second order design task. So we design games, but in themselves, those games are designing experiences for the people who play them. So we spend a lot of time thinking about audience and audience experience and the kind of experience that we want people to have, the kind of messaging that we want people to get through the experience of play. And so that also means that we think about process in two different places as well, right? We think about process in terms of how we're doing the design ourselves as designers, but we also think about the process of being a player going through playing this game for the first time and what they'll be experiencing as they move through it. So I tend to be very process heavy. The other type of design that I tend to do that I'll talk about very quickly is sort of affordance-based design or material-based design. So some games that I've been working on recently have been about quilting and textiles. So with April Groh, who's sitting in the audience in the middle, hi April. April and I worked with people at Disney Research Pittsburgh. We made a game that's played on an embroidery machine that has like an actual literal physical component. The winner takes home an embroidered map that's been sewn during the course of play. With my colleague Celia Pierce at Northeastern, we created a game called EB, which is a game that is also a quilt, and you're placing quilted patches down onto an electric, a game board that has conductive Velcro on it, and you're building circuits as you play with these physical material pieces. So we spend a lot of time thinking about what the materials will let us do and what the affordances of materials are and how that those become constraints and opportunities during our design process. So I guess with that, I'll pass it on to Ollie.
Thanks. So for this panel, we were asked to talk about computational creativity and design, and I think there's been a range of interpretations of that. So I'm coming at this very much from the similar point of view to the talk you just saw of Liam's, which I was also a co-author on, looking at how we're using interaction design as we go forward in computational creativity, applying our work in the context of users. And just one of the huge things I think that's getting extremely exciting is that people are actually using computational creativity systems out in the wild, and they're being used, they're being applied. Suddenly that means we actually have a user base where we can do lots more interesting research. We also now get to witness the gradual emergence of new forms of use and new, potentially entire new categories of creative practice that come out of this. So, for example, we're beginning to see that with people mucking around with deep learning visual image generation systems all over the web. Let me just catch up with my notes. That actually also means that as computational creativity becomes a serious set of technologies that are being used, we actually need to start thinking more about factors like social responsibility and thinking about how these are being used in political factors. So that's why it's fantastic that Gillian was organizing that workshop, which I look forward to. I couldn't make it, but I look forward to reading the papers. So, for example, I've become fascinated with the idea that all of our work will get turned into meme generating technology, which will win the next elections. And so bear in mind that you might be the makers of the next generation of evil technology. And we thought we were the nice ones. Something else that's changing is that the Kurzweilian vision of kind of robot artists walking the streets and exhibiting in galleries is being rapidly replaced by a much more distributed view, as evidenced by all of the work that's going on, and particularly the focus on co-creativity. So I think that's helping to normalize what we're doing in this field, and that's an important question for designers and for a design perspective on computational creativity. Design practice and design research is also a great source of inspiration for computational creativity research in terms of its interdisciplinarity, and it really is a phenomenal demonstration of interdisciplinarity from engineering all the way to anthropology and cultural research. So if you just think of examples like, I like these examples in design of a speed bump, which is something that slows cars down and stops people getting killed, and has horrendous other consequences like making people really irritated and making us burn more gas and our cars getting damaged more quickly. Every design issue you can think of pretty much has these complex social interdependencies and interactions, and we're beginning to face those kinds of issues. I was going to talk about the design of toilets in different parts of the world, but we'll come back to that. So also at the same time, cultural factors are becoming bigger and more prominent in various areas of design. And so it's not just about us learning from design, but also the potential that we are innovating in that kind of interdisciplinarity. And I think this community does that extremely well and is getting better at it. So that I think the pieces of the puzzle are really coming together in terms of CC, computational creativity being applied. I've just co-authored with Andrew Brown, it's in review at the moment, but a book chapter which is responding to third wave issues in HCI, which is looking at the more cultural and distributed and dispersed issues of human-computer interaction, and we'd welcome people if they want to get in touch to review a preprint of that. We'd be really interested in thoughts about that. And I think I'll probably wrap up because I'm just only about a third of the way through what I was going to say. Maybe just the last one. Yeah, it's actually just continuing on from that discussion about design being a great source of inspiration in this field. And I think we're also seeing people getting beyond a kind of fixation on things like Turing tests and blind tests and quantitative results, and seeing a more diversified approach to how we do methodology in this field, including qualitative results and in the wild studies and those kinds of things. Thanks.
Okay, let's thank the speakers for their pitches. Okay, so we've got 20 minutes for questions. I invite you to lob them fast and furiously. I'll lob this your way. Be creative in how you address them. Don't use their names. Use a description.
I was about to address this to the gentleman sitting on the right from my perspective, or Ollie, but it's also for all of you. So interaction design is starting to really appear in computational creativity literature, and I don't really know what it is and why it's relevant. So I figured this was a really good opportunity to ask. And if so, yeah, what is it? Why is it relevant to CC? And why should we be aware of it? What should we be taking note of? Bring it back.
I was really hoping that I just answered that question in what I was saying. So why is it relevant to computational creativity? Because I think, I don't know, there's a very simple answer to that, which is that we make pieces of software that people use, and it is the subject that helps, or there are various sub disciplines. Interaction design, or HCI, is the set of methodologies that help us understand what's going on there. Yeah, maybe do you want to jump in?
Yeah, I actually teach HCI, but in terms of designing any kind of description of something that's going to be realized, you have to think about interaction with it, not just computer interfaces, right? I mean, if you're doing, I don't know, Blender design, you need to think about people's fingers. Blended fingers are not fun. So, oh, sorry, people, squeamish people. But you do have to think about usability for games, for any kind of interface. You need to predict perhaps what their mental models might be so that they can understand the process of the thing. Is it really necessary to understand how the creative product was generated by the computer? I'm not sure it's totally necessary. Is it necessary to understand how the car works in order to drive it? Not totally necessary, but some idea might be appropriate. So you need that to build into the design, something about usability. And the interaction with the thing is part of the usability.
I think maybe the easiest way to describe interaction design is that it's the design of interactive objects from the point of view of the people using them, not the point of view of the engineers building them. So it's a set of practices, methodologies for crafting interactive experiences with objects that are not only free of frustration and failure, but also enjoyable, productive, pain-free, and other good things.
Sorry, I had one quick thing to add. I think in the context of game design, and I think this extends out to computational creativity as well, we have an overlap with interaction design, but it's not fully subsumed by interaction design. In that we do need to think about people and who's going to be playing our games, and sort of the player is primary in that sense, but we also spend a lot of time talking about authoring and what story we want to be telling through the game, or what experience we want to be conveying through the game. And I think that might be where I think about it in relation to computational creativity, whereas as CC researchers, we're making stuff that sort of has a creative voice, or at least we would like it to have a creative voice, or maybe I would actually argue in many cases we're amplifying our own creative voices as programmers of those systems. But if we're going to have people interface with it in some way, even if it's just viewing it, but especially if it's going to be interacting with it in some mixed initiative or co-creative capacity, we do then also need to be thinking about how the person will experience it. And I think in general, what design teaches me is to look for where the humans are in what we make. Right, whether that's humans as users, humans as us as creators, and thinking deeply about what our commitments are when we design our software and design our systems, or humans somewhere else in the process, right? But there's people all over the place, and we can't distance ourselves from the fact that there's people in all of our work, even if we would like it to be fully autonomous.
You control it. Just to continue a bit from that, but even if you were to make a system that was your Kurzweilian standalone artist, then you've still got interaction issues, and so and they're very cultural, they're very socio-cultural, and that's what's happening in interaction design. It's just increasingly becoming more focused on a cultural level. And so is software itself. Like, software is just permeating social interaction and becoming, in some respect, more cultural. And so an interesting part of that equation, I think, as well, is that computational creativity will be, in the next coming decade, really feeding that transformation. It will be part of that transformation. So again, it's not just about us borrowing those methods, but about us actually being quite significant contributors to that transformation in software.
Regarding the relation between computational creativity and design, one aspect that has been discussed just now is about the interactions, about that you have a computational creative tool and you look at the design aspects of that. The other aspect is as an applied area, the design. So how do you look at it? Because most of the applications that we are seeing, at least in this conference, are what was presented in the first paper as application, the music and the art. So design as a space for applied computational creativity, how do you look at that? And is it different, or is it just an extension of what we call usually as computational design? Just a question.
Yeah, I think that's a good. So I've done some work with what I would call design as a domain for computational creativity, as much as I'm increasingly disliking the word domain. But you can ask me about that later. So some of the work that I've done has been in procedural content generation within the space of games. So I've done work in computationally creative systems, arguably, that create levels that people will then play in games. Specifically, my PhD work, which is a long time ago, was around like procedural level generation for platforming games, so like Super Mario World or Sonic the Hedgehog. And there still, I think I'm thinking a lot about people, right? And there's this entire literature in the game AI research community around modeling players. Julian Tegelius, who's sitting in there, does a lot of work with player modeling, where we're trying to think not only about the artifact that we're creating, but how the people will experience the artifact that is being created. So I still tend to be very, very human-centric, though in maybe a different way than some of my colleagues are human-centric. When it comes to thinking about design as a domain for creativity.
So my first comment would be that, and let's set aside whether we like the word domain. Let's use it for now. Acknowledge it. Yeah, cool. We'll use it, and then we'll fight about it. I don't think design can be a domain, but particular kinds of design can be. Design's too big, but you can have a product design domain, a game design domain, an interaction design domain. You can product design still pretty damn big, right? Yeah, but you can design blenders, right? And that can be your domain. Or chairs. Chairs are a classic design domain. If you take a class in design, you always do chairs. You get so sick of them. But I think to your question of how is it different, I think I'm going to have to go with what Jillian said, in that it has a user who has a function in mind for that object, which hopefully is similar to the function you had in mind when you were designing it. And I think that's one of the defining differences between design and other creative domains, where the design has some kind of purpose. I think that you're right in that we tend to talk too much about requirements from very early. Requirements is maybe just a more dusty way of saying purpose. And you can abstract it out and say that you're designing a thing that is for a purpose, and that purpose is what you either start with or comes to you very early in the design process. And I think value-centered design, your values and the communication of those values, raising awareness of those values would be your design's purpose, or one of its purposes. And there's certainly not requirements, that's maybe the wrong word. But how that affects your CC system, I think, is a really interesting research question. How does building a CC system that is trying to create creative objects that have a purpose beyond communication and expression, how is that different from objects that don't? Good question.
One thing that, and I don't know anyone who's doing this, but I think it would be awesome if someone did this. When I think about design as a domain for CC, I do think we're still often in part talking about the product, right? Because we ground ourselves in the product that we're creating. But when I try to think about what it would mean for design to be a domain for CC, I move back to process. And I would, in some ways, love to see a project that is attempting to create new processes for design that are then enacted by human designers. I think it would be equal parts fascinating and hilarious. But I think that the duality of purpose and product and design is what's really interesting to me, and I want to keep trying to pull it back to process for myself. At least I don't think everyone needs to, but for me it's important.
If I gave you a blender, would you care how it was designed? It could be, it could have been done by some random drop of bricks and sticks on the floor and then reinterpreted as a blender. I mean, it doesn't matter for most engineering products how they were designed. it might change your point of view if you knew who did it, or but that's a different thing. You know, you buy it off the shelf and you evaluate it, and there are certain criteria by which you evaluate it. Obviously, the novelty and the surprise aspects are important for creativity assessment, but other things, obviously, you have to have some kind of value. It might be actual cash value, but it's much more likely to be ease of use, and of course, whether it achieves the function that you desire. But there are other things like, you know, does it feel like it was well crafted? Does it have like organic shape? Is it, you know, there's a whole bunch of possible things. And talking to someone else, as one author actually talks about 30 different ways, the attributes that are associated with creativity evaluation. I tend to think it's much more like 5, 6, 7, 8, 9, that sort of level. But you can reduce it down to novelty and value if you want. I've forgotten what the question was now. Was that enough?
Yes. Anyone else for these guys?
Just throw it. I'll just investigate.
No, wait, hang on. For the stream.
Yeah, stream needs.
I mean, requirements to fulfill.
It's true. You don't get paid if you don't read the stream. You don't get paid either way.
Don't pay home until Tony said 10,000 steps.
So I thought that was really interesting about it doesn't matter if it's like if they know how it's been designed or not. And I can think of an interesting counterexample to that, which is kind of the idea of customization of objects. Customization of objects. So you can think of there's sort of a range between customization and creativity. So for those who play video games, often you have a character creator. And the purpose of that character creator can be everything from I want to customize my appearance in this game for, you know, presentation purposes, or for things that get sort of very extreme, like Dwarf Fortress or Spore, or various other games, or like Minecraft, where it's about the creativity of creating something. How do you deal with design where you're kind of between this? This is an ill-formed question, but when you're between creativity and customization, like is there a space, is there a spectrum there, and how do you deal with
It sounds
ownership?
like you're putting the creativity in the user's hands there. Is that true?
I think in a lot of them, but then there's also a slider where it's like if I'm just changing the color of my shoes before I order them, how much is that creativity versus customization?
I like the Tony part of this gives us an
It does, yes.
And you do need it.
Yes.
I think this connects to the idea of routine versus creative design quite nicely, in that if you have a small number of sliders in a character customization thing that's for like brow shape and hairdo, and you're not, there's 15 now. I haven't had too much time to play computer games recently. It was 8 when I was last playing. Anyway, so the space is well defined, and your search strategy is very straightforward. Sometimes there's a random button, but most of the time you drag, and then you drag another one, and you drag another one. And that fits the classical definition of routine design. But there's a point at which the interactions between multiple sliders produce things that you would not have expected was possible. And then you have to ask, which space is important? The space that the programmers defined, or the space that the user thought they were searching? And if you find some emergent property of having this slider here and that slider there, now you're definitely into what we would consider exploratory creativity. You thought you had a good idea of what would happen, but if you actually set it to this beard and that hairdo, it looks like your character is hiding behind a bush all the time.
No, I'm not.
So there's clearly possibilities, even in customization with simple sliders, for exploratory creativity, if something emergent happens between the dynamics of different knobs.
Yeah, great question. And obviously it closely relates to the casual creators concept, which has been really useful for helping think about a particular area of computational creativity and how it's applied in design. So thanks for that idea. I think what you're talking about touches on, in an interesting way, a really big issue, which is why anyone's motivated to do anything in a creative domain, like compose a piece of music. Why do we do that? We quite often throw our hands up in the air about that when we set out to make computational creativity systems in any domain. We're all a bit stumped exactly, but it's something we need to look at more. And in the casual creators context, that's quite nicely framed in a way that we can study that. For example, it seems pretty clear that in a lot of cases, you just want something that's different from all the other people's avatars. So that's why you're doing that. And that may be for practical purposes in the context of a game to be able to identify yourself, or it may be for more deeply ingrained cultural reasons, like the development of an identity, and that might be cultural and it might be social. So I think that's an area where we'll actually see another interesting application of computational creativity, which is maybe not quite as lofty and exciting as people had in mind when they set out to make systems that might automatically create, but to support people doing this very casual form of give me something different, or ideally, I guess, give me something different that's also novel and valuable, whatever that means, is something that we'll see more of, and that would become an interesting thing to study. And I think just more generally in response to that issue, we do still need to get deeper into this question of why someone composes a piece of music, why someone paints a painting. It's a pain in the ass question, but it does need to be kept at the forefront of actually how these systems are being used and applied.
Get it away from you. We have time for a micro question and micro answers. Coming up on yes and no. Yeah, like that.
Do you use any supportive tools coming from computational creativity yourself? Do you use any tools, computational creativity tools, as a support for your work?
Come on, someone take it.
I don't use any computational creativity tools while making computational creativity systems, although that does sound fun. I don't actually do design, I just teach design.
We should end it there. Good call. Yeah, just cut the stream. Kind of like, so sometimes I'll write little generative systems to explore a design space that I'm thinking about. Like for thread studying, for example, the embroidery machine game, technically you're playing on procedurally generated maps that were then hand curated. And I don't think we would have come up with the maps that we were playing on without the procedural generator. But I don't think we would have settled for just random thing that came out of the generator either. Like we wanted the human curation in there. Similarly for like a generative design textiles project that I recently worked on with cross stitch, like I wrote a generator, but then there was a piece of me in curating the output from it. I do know that in like the larger space of design that I think is maybe not represented on this panel, generative design software is certainly used, right? So parametric design and architecture is a big deal. Autodesk has an entire generative design group that does generative design things and are thinking very carefully about what kind of interfaces should we use for these. And then we also think about like how obvious is it that a thing was made by an algorithm. So there's an article, the author of which I can't remember right now, who talks about how he can walk around a city and be like, that was designed with this piece of software, and that was designed with this piece of software, because it's got like a fingerprint to the software. So yeah, like it is used, but I think I always want, right now, at least in my design projects that are not intended to be computational creativity projects as well, I still want my final say. Or if I don't, like I want that to be an intentional choice that I'm making, I guess. That wasn't my
Are you going to wrap us up with that now?
Yes.
Okay. I have one, I hope, final plea, and that is that I constantly find a disconnect between those people interested in creativity in the design world and in this particular conference, which always seems to be much more artistic. And there aren't very many people that go to Design Computing and Cognition and to this, or to the Design Creativity Conference and this, and there ought to be more. And certainly there ought to be references to papers across the fields. And that's kind of sad. I know it's pretty difficult to follow more than one thing. You know, if you're focusing on your research, knowing what the hell goes on in a totally different area is very hard. But there are lots of comparisons. I mean, I would like to challenge those people who are doing, I don't know, say music design and poem design to think about how they might be modified to design bridges or blenders.
Where is it? Still at the thought. Let's everyone thank our bright demanding panel members.
Please, the members of the steering committee, remember what committee now, please. Somebody has lost a wallet. Is there money in it? I was just going to say that. If someone wants to take the water back, leave the money for me.